so it's perfectly mapped across the globe map. Great. So what about the analemma? Why is this observation where we always find that the sun has a small tight circle in the north and then a wide elongated circle in the south? Because that's asymmetrical, and the dual pole, I mean, would seemingly, I could understand or appreciate how you might be able to morph it a little bit such that there's something slightly different going on between the north and the south. But if that analemma, which is a natural observation you can make, I mean, I've never done one of these observations. I'm taking that it is true, the images that I've seen of it. But I mean, how would we resolve this? Because we have a widening at the southern circle in the analemma, and everyone here seems to be trying to suggest that this the GPs and the mapping across the surface of the Earth is all even between the north and the south.
Yeah. So the tropics are even. I mean, on a dual pole, they would be, I mean, conceivably, depending on what the actual, real layout is or whatever. And then the globe is pretty much, I mean, I know they say like slightly pear-shaped, but oblate, but for the most part, it's only like very minorly different on the larger scale is what they claim. So it's not like the globe is actually shaped like a pear to where it would be hugely, you know what I mean? They show us pictures of it like, yeah, it's essentially a sphere, but a little bit oblate or whatever. And they say a little fatter in the south, but it's like very minimal on the scale. So yeah, I mean, the 23.4 south, 23.4 north is essentially symmetrical. The analemma comes from, in the globe model, they claim that that has to do with the elliptical orbit of the Earth around the sun. And the elliptical nature of it is what causes that analemma effect, that when the Earth is tilted in the north, it makes a smaller loop because of the elliptical orbit of the sun. It also, or the Earth around the sun. It also has to do with what's called the equation of time. If you look up the equation of time, it explains, and I could go into it, but just for brevity. So there's the equation of time, which is linked to why the analemma and then the elliptical orbit. So it is symmetrical on the globe model in terms of the 23.4 north, 23.4 south, and the general sun distribution patterns, like on the globe model. But the analemma is not necessarily caused by the tropic distance from the equator, but it's claimed to be caused by the elliptical orbit of the Earth around the sun. And when you freeze frame the sun, at intervals, it makes that analemma pattern. Now, how the analemma would work on a dual pole is a whole question as well, and why that is an effect. Like, is there some kind of an elliptical nature to, like, I mean, are the circles of the sun oblong or oblate? Instead of the Earth being oblate, or is the sun path oblate? So yeah, there's some thoughts there. But
I thought it was called an enema. Yeah.
So Rixie, you see what I mean by that? That it's not really the distribution of the light on the Earth, that it's actually the elliptical orbit, but it is symmetrical in terms of the light distribution.
The light, so that'll be the daytime, nighttime, but the position of the GP of the sun is, thank you very much for all that explanation. It's, I have kind of jogged my memory as to a lot of the stuff I think you've mentioned before, but that's a great little concise package. What is it? The globe has a solution for it, although, I mean, it's a bit ridiculous to me, but I won't go into the details of why I think so. The AE map seems to resolve the analemma though. And it speaks to something going on differently in the south. There's a asymmetry going on there. I don't know, I just find that a little bit fascinating, because if we're going to try to make everything symmetrical because we need it to match up with this sun observation of its GP, but then the analemma is doing something kind of different there, like implying that there's a wider berth at the south. I don't know what to make of that. There's a disjunct there. Because it implies then that the GP is not necessarily matching up with, like, if you stay in one singular location on the Earth and you observe the sun, it warps a bit more. But if you were to follow the GP of the sun around, constantly taking those photos, I mean, it'd be directly overhead 90 degrees. And then I guess that I would be asking, what sort of pattern would you be inscribing on the surface of the Earth? And that'd have to be the sun's GP, which is almost like perfectly balanced. I don't know. I don't quite know what to make of that.
Yeah, no, I hear you. The analemma does. I mean, I've thought and talked about it over the years. Like, yeah, the idea that the AE map that it's making a smaller circle in the north and a larger in the south potentially would fit that analemma pattern, which is potentially compelling or interesting. We've talked about that over the years. Like, oh yeah, it's wider in the south, because it's always wider in the south and always smaller in the north. But that doesn't necessarily mean that has to be because the sun is making tighter and larger circles. Although I do see like what you're saying there with the overlap. The globe idea kind of works, but yeah, I mean they're using the elliptical orbit and then the tilt and so on, and like the whole like the thing where it's like 3 million miles closer, 3 million miles further, through the seasons and so on, as to why it's making that pattern. But I mean, like if you were to see the analemma has to also do like with the equation of time. So the equation of time is that like the day is like slightly different times. So that's why like when you're snapping the analemma, like it's in a slightly different position. But if you were just to track the sun between the tropics, it would make like an equal figure eight because it's like from 0 degrees to 23.4 north, and then from 0 degrees to 23.4 south, you would actually end up with like, an equal figure eight basically. But the analemma is caused because of the equation of time and the elliptical orbit and so on, so like I'm just saying it is like, it is equal in the way the sun moves, but from its distance from the equator, it is symmetrical. But the equation of time, the reason it looks like that is because you'll notice like the middle of the analemma is not in the middle of the kind of figure eight looking pattern. It's like up near the top. So obviously that's not 23.4, from 0 to 23.4 north, 0 to 23.4 south. Like the analemma, the reason that it makes that figure eight effect is not caused by the positioning of the tropics, basically. So it's caused because of essentially the equation of time and this elliptical component. But you see what I'm saying there? I'm just trying to respond like to what kind of direct to what you were alluding to in terms of
I mean, does that explain why it's hyperbolic at the south? Like why that extension occurs when it's meant to be like completely symmetrical? And it's just kind of curious that it's happening. Like if you pick your specific location on Earth, I think I've already kind of said this, but and you make your observation into the sky, then apparently the southern circle is always going to be larger. Yet if you were to follow the sun around, it's all symmetrical. I don't know, how is that possible? It implies to me that there's something going on there about observing the sky from a singular position upon the Earth, where you end up with this asymmetry. So yeah, once again, I don't know what to make of it.
Well, the equation of time has to do with like solar time versus like essentially clock time, like an actual clock. So like if you have a clock that's just ticking, that like just literally a clock ticking 1 second, 2 seconds, like the sun doesn't actually sync with that. Like the sun doesn't actually sync precisely to that. So it changes throughout the year, like as much as like many minutes, like I think it's up to like 7 minutes. Well, it depends on what time of year. It actually goes up to like 14
The sun
minutes.
is speeding up and slowing down? Or is the Earth supposed to be speeding up and I don't know, what does that mean?
Well, there's a difference between apparent solar time and mean solar time. So, but saying it simply, like if you just had a clock that was just ticking like, like seconds, that won't actually sync with the sun. The sun will waver back and forth from that, and it will waver throughout the year. So like if you look at this chart right here, this shows how it differs in number of minutes through the days of the year. So like 90 days to 180 to 270 to 360. So you'll see like in that chart, between 270 to 360, you have like a 14-minute, it's actually like 17 minutes when it's from that section. The other one is like 14 when it gets to that extreme. So basically, but they claim this is because of the elliptical orbit. Like if you imagine the Earth is going at a certain rate around the sun in their model, but if it's elliptical, it's going to waver. You know what I mean? Because like, the way it'd be like, woo, like the elliptical nature of it, actually, it's not just it's not consistent like a circle going around. Like if the Earth was like a perfect circle going around the sun, and it stayed at the exact same speed, then I guess you wouldn't have this issue. But the fact that it's elliptical, I mean, I don't think the Earth's a globe, and I don't think it's elliptical. I don't think that's what it is causing it. But that's what they explain in their model. Now there may be though an elliptical nature to the way the sun moves, the way the sky works, to where this is actually happening on a planar stationary Earth. And they have to explain it in the way that they do with the elliptical orbit, because everything's kind of transferable. Like if it's actually the sun making an elliptical pattern above a flat Earth, they're going to say it's the Earth making the path around the sun. You know what I mean? They invert it. It's all inverted.
Yeah. I completely understand that part. But there's an asymmetry. Yeah. But you said it's
So like time will
sub-solar time or something? I've never heard that term.
Yeah, like a sundial will give you like the apparent solar time versus the mean solar time. So like a sundial won't fit exactly to what like a clock is. You know, like if you have like a quartz crystal, would be like how we apparently view the sun time. You know, apparent sounds like just like what it is, apparent solar time versus mean solar time, meaning if you like average it, you know, so if it goes certain minutes faster, certain minutes slower, but then the mean of that's why like, it's not really that big of an issue. Like we don't have to change our clocks every, you know, all the time, because it's the apparent motion of the sun compared to like, we don't have to change our clocks, you know, to account for it. But you then get into like time zones and a bunch of other factors. But yeah, it's apparently the difference between apparent solar time and mean solar time. And the elliptical, because if the Earth was going around the sun in an elliptical fashion, then obviously when the sun is at like the, you know, the extents of that elliptical orbit, it's going to be tracking in its position to the sun differently than when it's at the other part of the elliptical portion, you know, of it. And that is what causes the analemma. So the analemma is not really caused by the distribution of the sun, you know, in its position between the tropics and equator. It's actually more caused by, you know, the actual difference between essentially clock time and then the solar time, the sun's actual motion. And then that causes, because that's what an analemma is, like you're getting a, you know, a snap picture of the sun's position, you know, and then that analemma reflects that difference between the clock time. Because if you're taking it at the same clock time, like you have a quartz clock or whatever, and you're like taking the analemma, well, it's going to differ from that. Otherwise, it would just track perfectly like in a straight line. But the fact that it differs, it makes that analemma a figure-8 pattern, which is also interesting with the dual pole. The fact that the analemma does that, and the dual pole has kind of a figure-8 sun pattern throughout the year, like circles one pole for 6 months, circles the other pole for 6 months. So even though you were saying the analemma might kind of fit the AE map idea of smaller in the north, larger in the south, I hear that, but also like the figure-8 pattern could fit with a dual pole type of idea too. The fact that it's doing a figure-8.
Yeah, I definitely agree that's possible with the dual pole. And supposedly there would be some sort of different quality to the south that would sort of cause it to elongate slightly. But yeah, anyway, thanks for answering all those. Much appreciated. Hopefully I didn't sort of, has anyone else got anything they want to run on with as far as the like this map comparison? I know Gatekeeper was pretty keen.
Yeah, we kind of went deep on that. I think I don't know what to call him. Funny, I guess. R Funny. I guess Mr. Funny had his name is just ridiculing people, so it's hard to figure out what to call him. But he
Yeah,
thinks flat earthers are funny. His name used to be Duncan. He had a name Duncan. Maybe we should just call him Duncan. He had something with the dual pole, I thought. Or if Gatebreaker, if you wanted to pick it up. What you were talking about?
I mean, that's really it. There's a lot more, but I don't have anything else to say right now.
What do you think about the analemma, the dual pole, equation of time, how that all works?
I mean, I would know how it's like modeled, but like how it works and the cause and stuff like that. I mean, I'm not too interested in that personally.
You don't have thoughts on how the analemma is formed on a dual pole, for example?
No.
If the sun is elliptical in its path above the dual pole or something to that effect?
I know its path. Take the analemma pattern, put it over the equator, the top end is the Tropic of Cancer, the bottom end is the Tropic of Capricorn, and during the year the sun is going back and forth between them.
Yeah, it essentially has to. I mean, if you have a planar surface and two 24-hour suns and the sun path, yeah, that's why I've been saying. I mean, people are always attributing like, oh, that I like believe in the dual pole, but I wouldn't really say that. Like, it does. Like I said, like I don't see any other way that it couldn't be a dual pole at this point, just in my journey of it, in terms of because the southern stars were always an issue for me. I mean, that's why like you'll never hear me like saying, oh, the AE map is perfectly what it is or anything, because I mean there was always that outstanding issue, and then there's just been kind of an unfolding of all these discussions and all that. But so yeah, and I mean I'm just saying if you have the sun circling around the North Pole, you can be there, you're hanging out, you see it, and then you travel, in a straight line. I mean that's hard to do, but let's say you were to then go to a South Pole, and then now it's circling you in the South Pole 6 months later, which seems like what it does. So I mean I haven't been to the South Pole, but then you would have two poles on a flat Earth, or I guess yeah. I mean they say it's a globe, but I don't think it's a globe. Gatebreaker. We don't have to get all contentious about it, but I mean, do you think it's a globe at this point? Like with all due respect, I'm not trying to fight you on it or anything, but is that what you're kind of just thinking it's a globe at this point?
It's spherical, inside globe or outside globe, but it's spherical, or it's some if it's not, it would be some which I don't know nothing about, but some higher dimensional geometry, which through our perception is essentially a globe.
Okay, but you don't hold the possibility that it is planar, stationary, and that there is a way in which like the sky, like the word hyperbolic came to my mind, but like hyperbolic geometry, or there's something involved that the sky functions with two poles, like in that stereographic projection or something to that effect. Like I don't think anyone with the dual pole really has like it nailed out enough, like very strong. I know. I mean, I think New Perspective's got a lot of in E1. Like he's definitely like got a lot of great stuff. So I'm not trying to say no, but I don't even think he would say he has all the answers either, though. And there's still things that are. I have a lot of open questions about it, but it's not problematic enough to me to be like, oh, it can't be a dual pole and it can't be, therefore it has to be globe. Like dude, for me to in any way, I mean, I'd have to see curvature, motion. I mean, there's a lot of things. Like, I mean, if you say that you like were a flat earther and then concave, like, I'm surprised you would go back to globe if you left the globe. But I guess I don't know what reasons you left the globe for, but just the indication of globe to me is so. Someone was asking earlier, like, what percentage, like, could it be a globe? I mean, extremely small. Like, I guess I can't say zero because I haven't mapped the whole Earth and I haven't done everything to know, 100%.
So,
I don't know if anyone does, but
so I do have a problem with the dual pole if I'm good to talk.
yeah, go for it.
All right, so I posted a picture in the chat. I'm not sure if you can see it, but I always understood that south was opposite of north and never like a 90-degree angle from north. I mean, correct me if I'm wrong.
South is always a 90. Wait, you mean 180 from north? Or what do you mean?
That's
180?
that's what I always thought, that south was opposite of north and never like a 90-degree angle from north.
Oh boy, this is going the route of like the Dead Reckoning versus, you know what I mean, versus the compass. This is the
This guy don't know
argument
which way east is, dude.
but he's using
No,
your
so, like,
argument
if you-
to make
it-
an
You don't know
it-
which
argument
way
against
south is either. I'm not
No,
shocked.
dude.
So if you look in the picture I posted, like I have the arrows, like red arrow represents south
Let's
and
go,
blue arrows
Spyglass.
represent north. And if you look on the equator, as you go away from the center of your picture, like north is that way, and then south is a right angle from north as you go on the equator, which just doesn't make sense.
He's still
Well, let me say that.
Jeremy's-
So, no, I mean, I know we're about to blast into an east-west thing, but there actually is like energy involved in this, in terms of this part of it, this discussion, because obviously the globe claims what it claims and it is what it is in terms of that. It's basically like a bar magnet in the middle of a ball, and then you have curvature and it goes around the ball. The thing about the dual pole is interesting is that you have two circles, and you could say you have east-west circles around, like if you follow your compass, etc. You're going to circle around them just like you would in the North Pole or South Pole, like 24-hour suns, etc. But then you also have like the straight line at the equator, which would be like a cardinal east, cardinal west, and then north south. Like that dual pole kind of looks like a compass, like these dual pole layouts where you kind of have like your 12 o'clock position, your 3 o'clock position, 6 o'clock, 9 o'clock. You kind of have those 4 points. I find that interesting, like the four corners of the earth. Funny, I think you're hot micing.
So,
Oh, hold on, let me just finish my thing here. I'll
well,
pass the
I'm
mic.
trying to.
Well, let me
Yeah.
hold on. Let me finish my thing. I'm going to post one thing, and then I'll pass the mic. So you have like the four corners of the Earth thing, which would be like 12 o'clock, 3 o'clock, 6, 9. So that's all interesting. But the thing is you would have like east west as circles around either pole, but then you would also have like on the equator an actual cardinal east, west, north, and south, etc. Now, lastly, I'm just going to post this real quick. This is just a bar magnet with the compass. What a compass does. This is a graphic, but you could do this with a real compass. I could pull an image. We've all seen this too. So, I mean, hopefully that might help with what you're talking about, because if this is the way the Earth is laid out, like the globe puts the bar magnet in the middle of a ball. So that's a little bit different. It is different. But on a dual pole, the magnetic system would work probably like this, meaning that the compass is going to act essentially like this does with the two respective poles. But yeah, go ahead.
Yeah. Do you see the picture I posted, Gio?
Yeah, the sun thing. Are you? I did see it. Yeah, there's something
Like, it
the
has-
the pink guy
Okay.
made, who puts everything
Well-
in pink. I'm assuming he made that.
yeah,
The
but then
pink guy?
I marked it up. So like, ignore the north and south, like running down the middle or whatever. Just like focus on the ones to the right and to the left. So like, which one are you looking at right now? The left or to the right?
Well, this thing has a bunch of things on it. It looks like you took something Pinky did, and then you added these lines. I see two
Yeah.
red arrows and two blue arrows that are like angled. Like, are those the ones?
So, are you looking at the ones to the left of the middle
Basi-
part or to the right? Which one? Which one do
Basic-
you want to look at? Which one do you want to focus on first?
You
I
want to
think I
look.
already know. I think I already know the issue you're thinking of, and I've thought of it too. So I think I already know what you're talking about, because yeah, the magnetic field lines, like they're like they arc out, like they're not straight, like the longitude lines are like. So then, like, do the compass lines like follow that? And then, but go ahead. I'm looking at the ones on the left. We'll go with that. Go ahead.
Okay. So, do you agree that the blue arrow is pointing to the North Pole?
Yes.
Do you agree that the red arrow is pointing to the South Pole?
From that layout, yeah. If anyone wants to see what we're talking about, it's this one. We're talking about the red arrow that's over like South America, and then the blue arrow that cuts up through, looks like the Caribbean and over Greenland. Yeah, I see those.
Okay. Do you agree that that is basically like, it's actually less than a 90-degree angle, but like, it's definitely not 180 degrees.
Yep. I completely agree.
So how do you solve that problem?
Well, I don't know that I have I mean, in terms of if the magnetic field works exactly like this with this layout, is north always opposite of south? That's what you're asking?
I mean, according to this layout, north isn't always opposite south.
It only would be right in Africa. It would only be right at the meridian in the middle, right? The straight line. Like if the
And is that the case? And is that the case in reality?
Well, I mean, we could get into like magnetic declination, that whole discussion of magnetic declination, because there's a lot of claims about how off it is in the south. And I mean, the claim of like where the South Pole is supposed to be like off in the ocean. It's not like at where the South Pole is in Antarctica. So there's that question as well. I hear you though. Yeah. I mean, if you were in like,
But is that
you were
ever
in-
an issue on the equator?
like just so everyone, okay, if you were in South America, right? You're in Chile, let's say. You're chilling in Chile, and your compass is pointing to the north. and then you have your needle going south. The thing is, on a globe, because the longitude lines are straight, essentially, they're like great circle routes. If you were to dead reckon south, like where the needle's pointing, opposite of north, you would end up at the South Pole on a globe. Whereas on this, and this is something I brought up to new perspective, and I don't know if him and I have fully talked about it yet, but on this one, if you're same thing, South America, you got your compass pointing north, everything's great. If you were to dead reckon south, pointing that needle south, you would not end up at the South Pole. You would end up off in the ocean, or I guess, I mean, Pac-Manning, but I don't think anyone's really saying Pac-Manning, but something to that effect. So yeah, I hear you. I do hear what you're saying. Like to go to the South Pole, you'd have to like basically go east from that position to end up there. So,
But like, have you ever seen a compass on the equator? Like, not like on the, I guess if you want to call like the middle one, the prime meridian or whatever. Have you ever seen a compass where you point north and then all you have to do is like a 90-degree turn to point it south on the equator?
well, no, but you wouldn't be pointing. Well, that's the question, dude. Like, how do the magnetic field lines work versus the Earth? Like the map is not the territory, kind of. But like, how does the actual? Because like, there's the idea that you're following the magnetic field lines, but as you follow those magnetic field lines, like for example, like roll with me here. Okay, let's say you're right at that spot, right? It looks like it's on the equator, a little bit off in the ocean, where your red and blue lines meet on your image there. Now, if you were there and you had your south needle was pointing opposite of north, but just like when you make circles, the whole argument of east and circles around the poles, well, think about this. Follow the field line. You're hot micing again. Sorry. Okay. But when you follow like the
I'm
field
just,
line, I know you got to mute or something
I-
though.
I'll try to mute. Yeah, hang on. Yeah, the screen.
You could probably change your sensitivity to where you could leave your mic open without it picking up, but or try turning on the crisp noise suppression. Anyways, let me just post this real quick. Okay, like this, the field lines. So imagine like, see, the thing is that as you would be moving, your south needle would move. So just like when the east-west thing and going around the pole and the compass, and as you start traveling east, your compass is going to change and you make a circle around the pole, right? Well, in that same idea, with what you're saying, you're also talking about a dead reckoning, with your needle south or a right angle thing. But what I'm saying is that if you were to keep following that actual field line, if the north south lines are actually following these curves, then as you were to be traveling in your thing on your red arrow, the south needle would continually change as you go. And if you followed that south needle, you would end up at the South Pole. If you dead reckoned, you wouldn't. But if you dead reckoned on a globe, you would. But on this one, you would. If you dead reckoned, you would not. But the compass would adjust if the magnetic field follows those field lines. You see what I'm saying? So that needle would continue to change, the south needle, basically the north-south thing. And because those lines are, kind of curving down to the South Pole, the way these work, the field lines like that, you see what I'm saying? The south needle, as you kept walking, you're going south, another step, another step, another step. The south needle would continue. Every time you take a step, it's going to move a little, move a little, move a little. And if you kept following your needle for south, you would end up at the South Pole with this type of layout. If you dead reckoned, you wouldn't, but if you followed the needle, you would. If the field lines follow, if this compass follows the field lines, which is why I posted the thing before. The same idea here. If you take yourself on this one, I'll pass the mic, sorry, but like right here, if you were between the red and blue right there, imagine that needle. See the red is pointing south, and then go one more to the right. See how the red is pointing more south, and then go one more to the right. See how the needle's actually changing as you travel. So if that's what's happening, then actually you would end up at the South Pole, and it wouldn't really be a right angle. It would be if you dead reckoned, but then we get into the whole idea of dead reckoning. Can you ever really make a straight line? How do you confirm that? But if it works like what I just posted, like the way a compass and a bar magnet, then actually you would end up at the South Pole. The needle would be changing as you're traveling, just like it would when you follow east and you make a circle around the pole.
I sort of understand what you're trying to say. I just don't think it like actually maps to reality.
Have you checked that though? Have you dead reckoned versus following compasses and actually traveled the Earth? And because that's what I mean, that would be a big project to check that, like to really verify the difference. You know, like if you're in South America and you're chilling, you got your needle. One of them is like, I'm gonna throw my compass away and dead reckon in that direction and see if I end up at the South Pole and actually have the machinery and the equipment, whatever, to do that. The other one is I'm bound to my compass. I'm on a huge Earth that I'm bound to my compass. I'm going to follow the needle. And with that dual pole, if you follow the needle, you will end up at the South Pole. Or
So
you
you're
know,
saying that
yeah,
all the north and south lines are actually curved in the dual pole model.
the line, yeah, it seems like it. That's what it would imply. Yeah. I mean, I'm not claiming
Like you
it's
can never,
that. Yeah.
like, never like, you know, pick a north like line and then just follow that line continuously. You'd always have to be correcting to follow the north line.
Yes. On that layout, I'm not asserting it. Again, I haven't. Oh man, your mic. Your mic. Yeah, I haven't mapped the whole Earth. I'm not claiming I'm like all knowledgeable that I have all these answers. But with that layout, it would imply that, yes, because on a globe, it's is the only one that it would be straight like that because the way the globe wraps it all, down around. But yeah, that you would have to follow the compass and that these lines are actually curved is what it would imply. And just so everyone knows what we're saying, I didn't even draw this very well, but I just did it super quickly. Basically, like if you were at the North Pole and you were going to follow your compass and you were going to go south on this map, that's essentially the path you would take across the ground. Literally a curve. Like you would go from the North Pole, your needle would point you if you just followed your south needle the whole time, you're just walking, following, you would actually make that whole curved path. Whereas on a globe, it would just be straight because all longitude lines are straight. They all go to the top of the ball, down to the bottom of the ball. And that is a big difference between the globe and the dual pole. And that is actually something that we could potentially test and see if there's a difference. If there's a way to dead reckon to figure out, are you actually making a curved path or not? Because you'd be going over the same land if it was a globe. Like if you wrap that around the globe, you would actually still be going like, over whatever Russia, go down the east coast of Africa. Like you would actually still be doing that path, but it's just because it's wrapped around a ball. It's different than on it when it's flat. It's actually like a curved line. I mean, that's how it's like, yeah, explained, considered. It's what it implies, and I'm just answering from that perspective. Just to give kind of a comparison to that, I did this really fast. Obviously, I'm just whipping it up on the snipper tool and drawing a line on it. But like that would sort of be the comparable on a globe, which kind of looks like you are following basically over the same land. I mean, I should have removed the cloud layer. You could have seen, but yeah, I mean, that is kind of the difference. And the globe one would be a straight reckoning path south, and the dual pole, you would actually be making a curved path along the ground. But it's like one of the hardest things to verify, though, like to dead reckon, to actually do that. And that's actually one of the things we'd have to do to maybe find out some of the differences between these. And it seems like something that is kind of easy for them to cover up, because who the heck is dead reckoning, you know? You got a compass always. Like if you're an ancient time person, you'd definitely be using a compass and the stars. You're not gonna. How do you take a straight line across the earth? I mean, you can hardly take a straight line walking across your city, let alone across the whole earth. You know, and then you got GPS nowadays. And you got celestial navigation, which uses the stars, so you don't really know what path you're taking if you're taking a curved or straight path. I think this is how they could be doing the flight deception too, with the whole flight path thing. I think it's very possible that planes are actually taking a curved path, a left to right or right to left curved path upon the ground. Because it's the same type of concept, you know? Oh, the great circle route on a globe, the straight line between 2 points. That's what they think they're doing, but they actually might be taking a slightly curved path over huge distances as they follow their GPS and their compass and their equipment. So I think this thing we're talking about is actually potentially how, you know, from the perspective of the Earth's not a globe, and the flight paths. People say, "Oh, we're flying around a globe. We all know it's a globe, right? Of course, the flight paths." But actually, this issue we're talking about could actually be linked to what they're actually doing on the globe. And I see Jeremy unmuting. Perfect timing.
Yeah.
You love this argument, or the related ones, but yeah, go ahead.
Wouldn't the flight data show you like if it's doing a curved path?
Well, they think they're following like a latitude line or a longitude grid path. They think it's on a globe. So they think, but yeah, I mean,
Yeah, but on a globe, they think they're doing a straight line, and it's actually, you know, because it's a great circle route to them. That's also a straight line, right? Like that's not actually tilting your wings.
right. So the two things I just posted, like the dual pole thing with that curved green line and the globe with that straight line, that's kind of the difference. Yeah, like the curved green line on that dual pole thing essentially is the great circle route equivalent, and it's a curved line. It's not straight. Yeah, but tilting your wings, I mean, you're talking about over miles and miles and miles. You're getting blown by air, you know, you're getting pushed to the left, pushed to the right. You have to keep readjusting. Would they really be able to actually decipher? Like, it's not like they're just tilting their wings like around a racetrack, you know what I mean? As if they're like, you know what I mean? It would be very, very slight adjustments, and they have to follow a heading and a track. So I don't know if it would be, it wouldn't really be tilting the wings. It would be like an extremely minimal amount over great distances that have to keep readjusting to keep on their heading, either with a compass, with a GPS, you know? So yeah, it'd be crazy if they're actually making curved paths along a flat earth and they think they're taking straight lines along a globe. Curving, they think the curve is 8 inches per mile, you know, and they're going around a globe, but actually they're going left to right. That would be a trip if that's what they're actually doing. But I think it could be pulled off that way.
It'd be cool to have someone that really understood software and was able to get into like a Boeing 747 or even bigger Airbus, like you know, like their flight control data, and to see exactly like in the back door or whatever. I mean, surely someone is able to analyze like what's actually going on, and maybe it's not even built into the simulation itself. It might be only in the physical planes where it's controlling like this flight path to where you're not even going to recognize it. Like even a pilot just wouldn't even recognize it because it's all built in and it's so subtle.
Yeah.
It would have to be really subtle, you know, and not really noticeable.
Yeah, well, I mean, the Globe guys will say that the plane doesn't have to tilt down because it's very, very minimal and, you know, over the distance. They just keep readjusting. They kind of use that claim when you're talking about the vertical up and down 8 inches per mile, you know, that you don't notice it on a globe. But what about left to right? Why would it really be any different? If they can write that off, same arguments could be made for this. And actually, the Globe guys would kind of be caught in a circuit, you know, kind of caught in that, because if they were to say, well, this can't happen, but the vertical can, but the horizontal can't.
I don't know if this is a silly idea, but
Wait, like as far as
go ahead.
go ahead. No, you're good.
I was going to say, like, if the planes are doing that, there may be a little bit of wear and tear that, like, on average in maintenance and stuff, would show up on one side of the, what are they, like, the gas pistons that they use, or what, like hydraulic pistons that they use, because it's ever so slightly turning left. Like vehicles, it's the, I mean, we drive on the, what is it, the left-hand side of the road here. So the vehicle on the left-hand side of all of our, the tire wears out more because you're more often turning right than left. There's all sort of like things about the nature of the way that you set up the roads, which causes wear and tear upon the vehicle. So it's asymmetrically wears, and I'd wonder if they are turning in a certain direction constantly, whether or not you'd be able to pick that up. But I suppose if they start driving back the other way, it might sort of even out, so you wouldn't be able to determine it. I don't know.
Well,
Crazy idea.
they also have high precision gyros too, the ring laser gyroscopes and the interferometry gyroscope equipment too, that picks up every little tilt of the yaw, the roll and pitch and yaw. So I mean, there could be an argument there, because that would pick up
I
all the
think
data too.
We
when a
already know.
plane turns, you've got to have the left and right controls equally balancing each other out. So it wouldn't be like the right-hand side of the plane wing moving and the left not. They both move in conjunction with each other the same amount to turn one way. So you wouldn't be able to distinguish that.
Well, they have to
They're
keep on
not
a
building
heading. They have to keep on a heading, and they got wind and things, and you know what I mean. Like, if you've ever flown, like you have to keep on a heading. So, like, if you've ever flown like a radio control airplane or a real airplane, there's a lot of little adjustments. So it's not like you would be. It's like this idea, like if you were on a track, like a circular track with your car, and it was like massive, like a 10,000-mile circle. Like, would you ever really like notice you're even turning your wheel left or right at all? You're just trying to keep straight. But I think Funny was going to get in, but Jeremy, you were go ahead if you only got a minute.
I mean, they'll already admit it, not in so many words. They'll fight it to the death, even though realistically, it's factual that they claim that they're not. Hold on. Even though they'll never come out and admit it flat out, they are flying. They are not flying the shortest path over the globe because they claim that they're adjusting for the Coriolis effect, which means they're turning left or right, and the shortest path would be where you don't do that. So, like, who knows what path? I know.
Yep.
Do the students at your school see you talking like while you're working? They think that you must have some special like CIA agent profile or something.
Like they'll admit, like the shortest distance on a globe between 2 points is a great circle route because you go from any 2 points and don't turn left or right. But then they'll fight me on the plane turning left or right due to the Coriolis correction, even though the shortest path would be where you don't turn left or right, like the great circle route.
He completely dodged you.
You know how you're at the North Pole and your back
Remy's fed.
towards the North Pole. If your back is towards the North Pole, everywhere in front of you is south, right? Is it the same at the South Pole? And is there a compass that can show you that if you have your back to the South Pole, everywhere is north? Do they make compasses where it has a south needle? Isn't there a claim there's two poles?
Like, yeah, they're just not flying the shortest distance even on the globe. So when we argue with these guys about distances and all this other stuff, it's like, dude, you're not even taking the shortest path. So like, how can you even? You can't even say anything. Like, you are turning. They are turning very slowly, Geo. They admit from the Coriolis effect, but the
Well, then
pilot
you
just
get
doesn't know it. But they say the pilot just doesn't know it. So you could have the same thing going on.
right.
You could have the same thing going on, like, oh, you're just turning to the left or the right very, very slowly. Pilot wouldn't even notice. Like, you could make the same exact argument that they make. And it'd be like reversing roles, basically. He's about to do it right now.
Do you think airlines compete with each other? Jeremy?
No, there's a monopoly in the sky
That,
for sure.
All right, you ask me a question, I'll ask you a question. We'll do a few back and forths. How's that sound? Is that
Yeah, sure.
fair?
Just answer my question first. Yeah, just answer my question first then.
I'm gonna ask you one, and then you answer mine. All right? Can we'll do that?
Yeah, so do airlines compete with each other?
I don't know. Here's my question.
You
You ready for my
you
question?
don't know if airlines
I
you
don't,
really
dude.
don't know if airlines compete with each other?
It's my question, dude. It's time for my question. See, this is why you don't play fair.
Okay, fine.
You don't play fair at all, dude.
Yeah. All right, fine. Go with your question.
Okay, is the shortest path when you're traveling to not turn left or right?
I don't know.
You don't know? Oh, okay, you don't know. So you don't
Yeah.
know. Go ahead. Do you have another question?
Yeah, so I imagine that airlines do
No, you
compete
know
with
what?
each
I'm
other,
good.
but they're
I'm good,
not
dude.
all
You're
by
just
the
saying.
same company. So, like, let's
I'm
just
good.
say that one airline is purposely like doing what you're saying, where they're like not actually traveling the shorter distance. If I was like a competitor airline, I would offer the shortest distance because I know that could save time. People don't like doing longer flights, and I know it would save on fuel cost. So, like, it just seems like it would be a very smart decision to like create a new airline that doesn't do these extra routes that take longer, more fuel, more time. You're paying your airline people more, all those things.
yeah,
You
I
would
got a
think that
question.
So
Do
in
you
a free
think Globe
market
is competing for
society,
the most unlikable person? Do you think
yeah, they
Globe is
do, but
competing for
I
that?
mean, obviously, they want to fly the shortest path because they claim that they fly in great circle routes because it's the shortest path. Now, why they're not doing it, why they're not flying the shortest path is beyond me. However, obviously, the shortest path, you said you didn't know the answer to this. I feel like you only said that because I said I didn't know the answer to your question. But however, the shortest path is when you don't turn left or right. And they claim they have to adjust for the Coriolis effect. However, very little, they still have to adjust for it turning left or right, which means they're not going the shortest path. You can avoid turning left or right by flying where the target's going to be, just like when you shoot a bullet. And they make their Coriolis correction. Same thing.
Yeah, they're making an actual curved path because of the.
as far as like,
Sorry, I was listening to on YouTube and then I flipped back here. Sorry, I might be a little bit off the convo. I was going to say something,
yeah. So,
but maybe it's not right what you guys are on. But yeah, but go ahead.
Risky, do you think airlines compete with each other?
I mean, it's quite, there's a monopoly in the sky, as I said before. But then when it comes to this idea of them truly competing with one another, like the idea of Qantas and I don't know, whatever American airline you want. I got feedback coming in. So imagine they're competing with one another. I don't actually think that they pick the specific. I mean, they'll pick the route, but not specifically the declination and all the details of that route. That's probably actually controlled by a centralized body or something, isn't it?
But like, if airlines were competing with each other, you would expect an airline to like come up with the shorter route to save on money, wouldn't you?
And surprisingly, they
They
haven't
know.
because
They never.
they all admit that they're turning left or right to adjust for Coriolis effect. And everyone knows, even in the globe model, which is why they say a great circle route is the shortest route because you don't turn left or right. That if you don't turn left or right, that is the shortest path. So you just have an argument from absence or something because they didn't do it yet. They didn't think of it yet. They're not as smart as me. I don't know why, but they obviously haven't done it yet.
You don't
Or
think
this
an
is where
airline
the
is
on this
smart
point.
enough? You don't think an
You
airline
want
is
to
smart
focus on
enough
this
to
point
know
that they're
that
not
the
as smart as
shortest?
me. I don't know why.
You don't think that an airline is smart enough to realize that the shorter path would save on time and money and
But
like for all those things?
Qantas doesn't pick, or
They
Virgin
clearly
Airlines
have
doesn't
not
pick the
figured it out
direction.
yet. Oh, go ahead, Rick.
Or it's part of the deception, Jeremy. It's not just that they haven't figured it out. It's that the higher ups have it set up in a way that the pilots that just went to school and they're just, waking up eating Cheerios and having coffee and just going to their job are just following what the path that they're given, essentially, and all the equipment that
Or
they're
they,
given.
yeah, it could be
That would be an answer.
it could be part of the deception, or it could be they just haven't figured it out yet. Either way, they're not flying the shortest path.
Do you know how
Yeah,
hard this is to figure out though? Like what Dude, we would
Not that
have
hard.
to have like a whole team and months and millions of dollars to even do a lot of these tests to really, you know what I mean? So who's going to do that? No one's, you know what I mean? Most people just believe the globe, the whole, you know, the whole thing, like to really, you know what I'm saying? Like to validate, like, because we're talking about how, like, what path are you actually taking along the ground over great distances? You know what I mean? Like, are you making a slight curve or not? Like, dude, you'd have to have a specialized team. Like, that's not something that you could just, the dude who went to school to be a pilot, who, like I said, waking up eating Cheerios and drinking his coffee, he ain't, he wouldn't know the difference. He wouldn't be able to check this to confirm it.
Airlines aren't picking the path. That's done by like air traffic control, like providing all the direction. The airlines select the route, so they'll say, "Oh, looks like there's a bit of a market jumping up for people wanting to travel from the west coast of America to the east coast of Australia. We should provide an airline along that route." Hey, traffic control, which path do we need to take? Oh yeah, thank you for the direct instructions. We're just going to follow those. And they don't compete in the way that I think you seem to be suggesting.
Do you think that the airlines have a bidding system? You know how contractors bid for government jobs. Would they have to put in bids like for a particular route, and then whoever gets the lucky draw gets to do it? Is it kind of like that? You think?
I'm not sure who you're asking.
Risky.
You're axing Rexky.
You're asking me? Oh, yeah. I thought you were asking Flat Earth.
You know how government offers jobs and contractors all put in their bidding, and then whoever's got the best price or best value, the government gets to choose. So would that be the same for the airlines? Whereas they set all the paths and they set all everything, and then the airlines just do their bidding. So it's kind of like it is a little bit competitive, but it's controlled at the top, like for the paths.
The government lay the roads on, like the pathways on the road, and they decide where the taxi driver needs to go. That's all it is. These guys are just basically yellow cabs or whatever cab system you guys have got, and they just follow the roads. I don't think that they're really competing in the nature of like, hey, air traffic control, we can cut off 30 minutes and save on fuel over here. Can we do that? Traffic control
No.
goes, nah, you got to follow this line because you're going to cause chaos in the sky. They've got strict lanes that they try to run down, as far as I'm concerned or aware.
You got the civil aviation authorities, right? I guess that's like a branch, right? And it says what they do is they regulate the airspace, approve routes, enforce safety rules. So the airlines have no say in that. The airlines don't even own the airport, so that's kind of like
You think it's like
they don't
one
own air
central
traffic control.
agency?
So I don't know
You
what
think it's
point you're trying to
you
make.
think it's
Yeah, I was
one
almost done, dude. Holy shit! Every time, man.
you think it's one central agency controlling every single air traffic tower
No, I
in
just
the
explained it. You
entire
have your air
world?
traffic control, you have your civil aviation authorities, and you have like different, you have the airlines, and you have different governing bodies. It's not
Okay,
like
so
they own every aspect of the air, right? There's oversight.
Well, then you
Like
get into the
everything that,
military, yeah, the GPS and military component of all of this,
yeah, like
especially with
everything's
commercial airlines.
compartmentalized. There's department upon another department, and they all like work together to say, and then there's a priority system. The military is gonna, or government is gonna take
Well,
uh priority over everybody else. And then
Yeah, but
yeah,
see,
all
then
the
I think
routes
about,
you're gonna get.
but no, I hear you on all that with the airlines, and there is a connection with the military. But then you, in terms of the whole flight system, is what I'm saying. In terms of the GPS systems and the flight paths and the approved flight paths and everything else. But what if you were just like an independent person and you have your own jet? You know, you're a billionaire and you have your own jet and you want to fly around. We were saying, well,
No.
what about that? Then people could confirm it. But even that, those guys are following GPS. Those guys are following compasses. Those guys are following flight paths as well, you know, to get approval to fly XYZ. They're not just taking, straight, they're not just shooting off into the Pacific Ocean, just, trying to track straight lines or do straight headings or anything like that either. Like they're also linked into the system as well. So that's why I was saying, like, for us to do it independently would actually be a huge project, to actually, even with our own private jet, to even confirm this. So
Yeah, even like if you own the
well,
plane, you
do you
have to
think it
report to
only
somebody.
applies internationally though? Like, it's quite possible that they do fly straight direct headings with inside the US, for example. But as soon as you get into international, you have to follow follow the rules, the international rules, right? And the international paths that are set there. But maybe within the states, it's all straight lines.
Now, if you want to take your plane in the air, you have to get your flight route approved. You can't just say, hey, I own a plane, I own a runway, I'm going to go out for a ride in my plane. No, you have to like contract flight control, you have air traffic control, like all these things. You have to make sure it's okay to go up in the air and then get your route approved. Otherwise, planes would potentially
Depends
be
on how
crashing.
high you stay, but
yeah,
either
not
way, they
enough.
claim that they're.
Please don't.
Oh, I thought you guys were done. Hold on.
Go ahead, Jeremy. I was just saying that you don't have to contact and do a flight plan every time you fly.
Really? So I could just take a plane out and just fly around?
Sure can. There's places you need to be aware of where not to be, but yeah, you can, as long as you avoid restrictions that, or if you fly into like Class C or B airspace, you have to contact the tower from 20 miles out, communicate with them so they know where you're at. But otherwise, yeah, if you stay below 1,200 feet above the ground, you don't have to talk to anybody.
Yeah, you can
Oh,
fly
okay.
around in short distances and at lower altitudes, but I mean, left lane, you're not just going to fire off across the Pacific Ocean without using GPS or
No. If you do fly a long route, it's a safety thing that I would get what they call flight following, and just ask the wherever the center is that you're under their jurisdiction to track you for safety.
They claim they're flying in great circle routes on the ground, and they're adjusting for Coriolis the whole way, which is a left or right turn. If you don't turn left or right, you just won't hit it, despite what anyone thinks. It's like when you shoot a bullet. If you don't correct for if you just shoot at where the bullet's going to be, you'll never hit the target because Coriolis is happening. So you have the same thing going on with planes where when they take off throughout the course of the flight, they have to turn a little bit because they take off aiming at the airport. They're always aiming at the airport they want to land in. That's the great circle route on the ground that they claim that they are flying.
Yeah, but Jeremy, isn't it a trip like the thing that the guy Funny brought up, which is that ironically, a great circle route on that dual pole is actually a curved path on the ground. It's not straight. And then what you were just saying about the Coriolis and how they even admit they're taking a curved path, but they claim it's because of Coriolis. Isn't that kind of
they say they go straight in one frame and curved in the other, but in all actuality, the plane is taking a curved path because the pilot is turning. You know what I'm saying? If they were just doing what the bullet was doing, I'd be like, all right, that's the shortest path. But yeah, no, I hear you.
By the way, you guys, this image here, which I have this saved in my folder, this kind of describes what Jeremy's referring to. Like if the blue thing was your plane and then the red thing is your destination, as you start flying because of Coriolis, and then it's going to actually be moving. So like you'd be taking that actual blue path. You wouldn't be taking the green. There's a couple other images that show it too, but yeah, the curve.
Yeah, that's from the inertial frame. Like if you were out in space watching it.
Nope, not from the inertial frame, from space, from the people on the plane. That's the inertial frame.
No, Jeremy. If there's an airport, I'm in the north somewhere, and there's an airport 1,000 miles south of me, directly due south 180 degrees. I will fly 180-degree track, airport to airport.
Yeah, you're always flying at the airport, sure. And if Coriolis is at play, then if you don't turn, you won't hit the airport because Coriolis will throw you off your track, just like when they shoot the bullet. You can't turn a bullet. That's why they have to shoot where the bullet's going to be.
That's why we have controls.
I know you have controls. You're turning the plane left or right, which is not the shortest path. Obviously, we know the shortest path. Everyone,
not turning.
If you take off flying at the airport and you don't turn left or right, if you're not turning, then there's no Coriolis effect. Because if there is Coriolis effect, you'll never hit the target. You have to adjust for Coriolis effect on a globe that's rotating. You could try to say you're not turning left or right. That's not even the mainstream claim. They
I mean,
claim they're
we
turning left
talked
or
about
right
it
ever
time and
ever
time with
so much
crab.
that they can't even.
Whatever force is
Go
acting on
ahead.
you, you point your thrust in a direction such that you maintain that track. You can be flying 180 degrees with the nose of your aircraft pointing at 210 degrees and still fly that 180-degree track. You're not turning, you're just flying sideways, sort of.
No, this is 100% steel man of the globe. Uh, if you shoot the bullet at the airport, you're not going to hit the airport because the Coriolis effect will have veered you off your path. Same thing as a plane. If you took the plane and just flew the bullet's path without turning left or right, you would never hit the airport because you have the Coriolis effect. You're not even steel manning the globe correctly.
Yeah, ballistic trajectory and airplanes don't follow the same path.
I know it's an analogy to show you that you have to turn, otherwise you won't hit the target. You won't hit the airport if you don't turn. You got any other brain busters?
Now, I'm telling you, you fly a direct path, 180-degree track across the ground. You do whatever you need to do, crabbing or whatever you need to do to make that plane track 180 degrees, and you fly that straight path, airport to airport.
You don't fly a straight path. The mainstream claims that the pilots adjust for the Coriolis effect. Even though it's so slight, they don't even know, which means adjusting for the Coriolis effect is a left or right turn. You have to, like I said, otherwise, according to the globe model, if you don't turn left or right, just like the bullet, when the bullet gets shot at the target, if you shoot the bullet at the target, you're not going to hit the target because the bullet can't turn left or right. You would do the same thing if you couldn't turn left or right. You would never hit the target. You're not stealing. You're straw manning the globe. I feel slightly
No,
embarrassed
I'm
for you right
not
now.
commenting the globe. I'm a pilot
I'm.
telling you how we fly.
You're straw manning the globe.
So besides the
You
globe
guys
and
can't
any
steel man the globe.
projection of the
I
globe,
don't even know why we
right?
talk to you guys.
So besides the globe and any projection of the globe, right, on all flat maps, the path that a plane takes is curved, isn't it? Like diagrammatically, like explain is shown to be curved path, unless it's on the projection of the globe. Is that correct, Left Lane?
Yes, the great circle on a globe looks like a straight line, but if you flatten that out, like we see on maps on the
Right,
screen or flat maps, it's a curved line.
right. But you can still have a map like that, and it shows the flight paths as looking like curved, but in reality, you say they're not curved. But it still has a north and a south compass, like stamped on that map, right? With the
Yeah,
equator in the middle.
when we fly magnetic headings, we have to accommodate the deviant, the variance or deflection. Different people call it different things. If it's like if the magnetic heading is 3 degrees off, we'll add or subtract that to or from our heading so that we can fly what they call true, true heading.
So, so do you think that the ships in the ocean, they on a flat map, like I was just describing, with curved lines for their, to show their, do you think their ships are doing the same thing? Like the shipping paths are also doing great circular routes and that, same as airplanes?
I guess you could cut. Yeah, I guess it would be if they're flying or boating a direct path. I guess they would be also a curved path. A long way if they went a long distance. I guess it would be.
So they're probably
Yeah, they're turning the
controlling the
plane left
shipping
and
lanes.
right, dude. Of course, it's a curved path.
They're controlling the shipping lanes as well. Then, I mean, they're controlling that as well to make us think that they're going in a straight path, but it's actually curved.
Kind of
No,
like how the
it's a straight
parallels aren't.
path. It's a straight path on a globe, right? But in one frame, in the inertial frame, you're actually
We don't use
curving.
the we don't use
That's
the
the frame
globe to
that
navigate
matters
though.
because I know I'm just saying that's the frame that matters because that's the frame the plane's actually in. You know what I'm saying? That's where the plane is. It's what the plane's doing. That's the frame where you don't want to turn left or right in.
Damn tree huggers gave me an oatmeal coffee.
How about the parallels not being actually parallel? You like that, brain buster?
Just literally like straw man. Unless you take off flying where the airport's gonna be, then you don't have to turn left or right due to the Coriolis effect. Right. But if you're just like the bullet or any projectile, if you shoot it or whatever at the target and there's a Coriolis effect, you're not gonna hit it. That is a steel man of Coriolis effect.
So,
Can you
Jeremy, do you think
acknowledge
it's
that?
possible that they could be using that the actual path that planes are actually flying, like, okay, so like a great circle route, like I said, like, here, since I took these images, you may not be able to see the chat, but for anyone else listening, just to be clear on what I'm kind of linking this to. So, this path here, like on a dual pole type of a layout, that green line essentially is a great circle route. It's one of the longitude lines, and it actually is a curved path. Whereas on the globe, I drew this very like just quickly and whatever, but on a globe, generally that's a straight line, a longitude line. Those are sort of comparable, you know, in terms of like from the north to the south and going to the right of Africa there. So, Jeremy, do you think that this Coriolis argument that you're talking about and the planes not flying the shortest route and the adjustment and the curve path, straight, all that, do you think it's possible that this could actually be like at the seat of a part of the deception where the planes actually are flying on a curved path along the actual ground, like in reality, but they think they're flying great circle routes? In this case, that's my question to you. Do you think that's possible? That it's like we used to joke about hidden in the winds, like hidden in the Coriolis. Like, could the deception be hidden in this part of it?
100%.
Or maybe this magnetic heading that our compasses point to is actually not where it is. Maybe it's like under the lines, like ley lines under the ground.
But Jeremy, you think it's possible they could pull this off though, and the people that like they wouldn't actually know because they think they're adjusting, they think they're taking or adjusting for Coriolis in the slight way, and it literally is wrapped into it, and nobody has been able, like none of them have like, because like what we would have to do to
Yeah, that's
physically
been the
confirm it.
argument, Geo.
Yeah.
That's been the argument for years. They're adjusting for the Coriolis effect. It's so small, they don't know they're doing it. That adjustment is a left or right turn, despite what the pilot thinks. It's just Coriolis physics. He can't. It's straight Coriolis physics. If you don't turn left or right, you're not going to hit the target. Whatever you want to call that, crabbing, lagooning, lobstering, whatever that is, you have to do it. Otherwise, you will not hit the target. So, but they say the pilot doesn't even know. You know what I'm saying? So could they be turning and not know it? Yeah, they already claim they're doing that.
That is intense, dude. Right, and they don't know what. Why? Because to know, like, what would you think they would have to do to know? Like, because like I was saying, like we'd have to have like a research team and years and a lot of, you know what I mean? It would take us a lot. You know, we will do it, but I'm just saying, like, it will take a lot. It would take a lot to actually do it. So
I don't know how you would know over that distance. I know how you would know over a very tiny distance. You put an accelerometer in the Foucault pendulum.
no, I'm saying whether to confirm, like, if we took a flight from, like, in that one I posted, that kind of dual pole, like, let's say to the north side of, you know, Norway, Russia, whatever's up there, all the way down to basically Antarctica. But even if we went down to like, what is that, like Tasmania or something off of like the coast of Africa there, how we would confirm whether we're actually taking a curved path along the ground or a straight path. Because the globe, in terms of on the actual ground, I mean, that's what's so difficult to confirm. So I'm saying it would take like, even to have a research team and all the money and everything all going, that would take a lot to even confirm. I don't know whether we would do it over that long of a distance. Like you were saying, we might do it over shorter. I guess what I'm getting at is that if the pilots are thinking they're adjusting for Coriolis, they are actually making a curved path along the ground, but they think they're adjusting for Coriolis. Great circle routes are not straight lines in reality. Like they think they're doing that on a globe, but they're actually taking a curved path. That's just a pretty big claim, like this guy John was in here earlier just going wild in the text chat with all of his capital letters and doing all of his just freaking about it, saying
You
that
talking about John, the guy that doesn't know if we drive, if a car hits a tree, he doesn't know if the tree moved towards the car moved towards the tree. That John?
That's the one.
That's brilliant.
But he's going off about how we know straight circle or great circle routes are straight. We know, it's just like dogmatically asserting what he thinks he knows. But what I'm saying is that like, for the even the pilots to be in a way like this is just right under their noses. I guess what was like, I mean that great circle routes are not actually straight paths. They're actually slightly curved. That's what this would imply, that on the actual Earth, like what the Earth actually is, that it's not, because obviously like for them to deceive us what the globe is, there's differences, and some people like are incredulous, like how could they deceive us about this? It's so obvious, and this and that, and we know longitude lines are straight lines, we know great circle routes. But if that's not the actual case, and then we're talking about how it could be pulled off and whatnot, but like, what would it take in your mind to confirm the difference to where a pilot who's just a normal dude, like I said earlier, who wakes up and eats Cheerios and has a cup of coffee, and if it's happening under his nose, what would he have to do to be like, wait a minute here, am I actually taking a straight path upon the ground? Like what would that even take to do? You know what I mean? Because when
over that distance, I have no idea. The pilot couldn't do it himself, I doubt.
That's what I was saying. It would take a whole team and plotting things along the ground. Like if we could make a straight line on the ground.
No, you can plot your track across the country, and you know what cities you're going over and what mountain ranges you're going over. You know what's under you. You don't have to look at it because they've got all the computerized stuff. But if I wanted to and had a plane that would go that far, I could fly by paper, a particular heading and use checkpoints, and basically the same thing. It's just manually old school.
Okay, but how do you know that path is actually straight and not slightly left to right curved?
Yeah, no.
That's the thing. The whole thing about the globe, like if you're flying in it, see, this is kind of inversed, which is interesting. So like in general, if you're on a globe and you were going a straight circle route, let's say you're on the equator, right? A great circle route. You're on the equator, you're going straight, everything's great. Well, yeah, you're not turning left to right on the equator on the globe, or really on the dual pole, you wouldn't either. But nonetheless, on the globe, though, you would be doing the 8 inches per mile squared drop. And then there's all the arguments around that. Like, are the airplanes tilting their nose and they wouldn't notice? Because I guess with that one, you have like a gravity thing, like clinging to the center of a ball. And that some people would claim like, oh, the gravity is like pulling the nose down, or like there's the different ideas, right? But like in general, it has to do with like, yeah, you wouldn't notice as it's so small. The thing is, though, left lane, what if that curve, instead of vertically 8 inches per mile dropping, is actually horizontal 8 inches per mile squared, to the right or left?
I'm trying to plug it in mentally. I just can't see how it would be. I don't know the the headings that are on the maps and the headings you fly, it would all have to be somehow wrong, and I just can't imagine how that would be.
Dude, you don't even think you're turning when you don't even think you're turning though when you are. You're fighting me to the tooth and nail on this.
I'm just telling you, it's not a turn, Jeremy. If there was a straight road from one airport to the other on that long north and south route,
yeah,
I would just fly over the road. I wouldn't even have to use my compass.
You would have to turn.
Same thing.
Have to turn. Yeah, no, you would have to turn to stay on the road.
No, you wouldn't. You just grab it.
You don't know the Coriolis effect. If you do not
It's
turn
the
left or
track.
right, you will
It's the
not stay
track.
on that. I know you have to rumpus this part of it. I know.
No, it doesn't. No,
I
you're
know you
wrong,
can't
Jeremy.
stop, dude. Just stop. If you don't turn left, you cannot steel man the Coriolis effect. If you don't turn left or right, you will 100% not be able to stay on that road. You don't know the Coriolis effect.
So
Okay,
a
you're
turn,
demonstrating right now how you don't know about the Coriolis effect.
a turn indicates a change in direction, right?
And if you don't change your direction, you will not stay on that line or the road or whatever straight line
No,
thing you have on the ground with the Coriolis. You
no,
don't know how the Coriolis effects works. You're demonstrating it right now.
yeah, you're
It's
just
impossible.
wrong about it, Jeremy. You're just wrong about it. So
I'm not wrong. That is literally anyone can do this right now. Find something spinning, draw a straight line on it.
If you're gonna say a
Then
turn,
spin it very slowly. Then spin it very slowly and try to keep your finger over that line without turning your finger. It won't happen. You can't do it. That's not how the Coriolis effect works. You can't steel man Coriolis.
Can I get in after? And someone else on the live there wanted to go too.
oh yeah, I was just gonna say if you try to
Anyone can try
argue
this.
if you try to argue
Answer.
turn is change of direction, then you can't say the small circles are circles.
So I got a question
I don't
for
know what
left
that
lane.
means, but anyone can. Go ahead, Rick.
I was just going to ask, like, just to get him back in, like, in artillery or sniper rifles, right? The claim of the Coriolis and needing to account for it, you essentially need to lead the target. Is that correct, as far as the claims of sniper rifles are concerned?
Yes.
yeah, long shots. Yeah, you would.
Well, I mean, it depends on the direction that you're shooting, right?
You would either you may drag. I'll call it drag. Shoot behind the target, depending on which way it is.
or you may shoot high, or you may shoot low if you're dealing with Edbos.
All right, but then when it comes to planes and you're shooting your target, you run in what, a straight line? You think? Are you leading the
mean
target when
planes?
it comes to the plane? Like, well, I mean, you're taking off from one location, you're going to a new location, hopefully a straight line. Are you leading the target or not?
No, not
He's
leading the
not leading the
target.
target.
Why
Yeah,
not?
because you're constantly correcting course. The reason why you have to lead the target with the bullet
Oh, here we
is
go.
because the bullet can't change direction in the middle of the flight. Well, when you depart that bullet, the moment it leaves your rifle, it's on you cannot change its direction. That's why you have to lead the target, right? Whereas an airplane, it's like a missile, right? It can make a turn to go to the target.
That's got nothing to do with it. When he's saying he's heading
No,
from
that
A
has
to
everything to
B,
do with it. Hold on, Ricksky. Ricksky, hold on. That has everything to do with it. Jake just said you have to turn to hit the target in a plane. He just made my whole argument. Thank you, Jake.
well, I was kind of agreeing with that. I was just going to go at it a different way.
That's my whole argument right there. Left lane is turning. He's just not admitting he's turning. Jake just said you have to turn or you won't hit the target. That's why the plane can still hit the target because it can turn.
Maintaining a constant heading is not turning.
You're debating with Jake at this point. You're debating with
Yeah,
Jake.
can you guys resolve your position, please?
Well, I mean, it's no different than a crosswind, right? I mean, that's basically the way that that it would present itself in the aircraft would be like a very small, like a few mile per hour crosswind, a very very weak crosswind, right? And airplanes have to sometimes contend with very strong crosswinds, right? Where the airplane would basically be in a constant turn to maintain its heading.
No, you're
So
talking about
they'd be
crabbing.
adjusted for it, but they would never know.
That's like crabbing. He's talking about like strafing or crabbing or whatever. I think we're getting conflated between the idea of the
yes.
Well, crabbing is a turn. It's an arrow.
No,
And
crabbing is not a
aerodynamically,
turn.
aerodynamically, it's a turn. It is a turn aerodynamically as far as what the airplane is doing in reference to the air mass, right? Except that it's doing that in order to hold a certain position over the ground. But aerodynamically, in reference to the air mass, it is making a turn in reference to the air mass. And airplanes are flying in the air mass, right? It's like a boat. It's like a boat that's trying to get to the dock across the river, and the river is flowing rapidly. The boat will have to crab up the river to get to the dock. In reference to the mass of water, the boat is in a turn.
It's not turning. It's not a call
12
to
higher.
turn. You wouldn't call that turn. Left lane, could you please? I don't know. I don't even know which way you'd go left lane. Do you think crabbing
Jake's
is
just
turning?
debating with left lane. Jake's debating with left lane
Yeah.
at this point.
This
So
is globe on globe action. I love it.
Yeah, I mean, yeah, if you're saying turning, you're indicating a change of a heading. And if you've got the crosswind, you're going to point the thrust of your aircraft into the direction of the force to compensate for it trying to blow you off, but you're still flying the same track across the ground. So you wouldn't say turning in airplane terminology, you would say crabbing.
okay,
All
but
right, that's
in
one
realistic,
point for
in real
Jake.
life
1 point for
terminology,
Yeah, but
left lane.
aerodynamically, it's a turn. That's why an airplane has a maximum crosswind component because aerodynamically, it cannot sustain anything past a certain level, right? So
He's, t-
aerodynamically, it is a turn.
That
he's telling
doesn't
you how to
make
fly
sense.
left lane.
Yeah, no, it's not. It's crabbing. It's not. Crabbing is not turning.
you literally
Okay, so why do aircraft have a maximum
you
crosswind
literally
component?
can't get to the target.
Because they don't have enough rudder authority to crab strong enough to accommodate the crosswind.
Great. So aerodynamically, the plane is doing what when it's deflecting full
Actually,
rudder?
actually, it's called a slip. Is if you want to get into the terminology, it's called a slip. It's not a turn.
In relation to the air mass, is the plane moving with the air mass or is it going in a direction different than the air mass?
Well, we're not flying to a destination in the air mass. We're going to a destination on the ground. Therefore, we need to maintain a constant heading, and we'll adjust trim the aircraft to make it go down that heading, even if it's sideways.
Sure.
Okay,
Oh,
just on the
I got a
Coriolis
question.
effect, Jake, if you okay, go ahead.
It's for left lane. If I keep a constant heading of 90 degrees from north, am I turning to make a circle?
No, not that. I
No.
guess you would have to over a long distance. You would have to. I don't
So
know.
keeping a heading is turning now?
That is yeah. That's a little bit of a nuanced question there. I don't know if I would call that. I guess you
Interesting.
would be overall. You would be, but that's
Yeah, I wonder
sort of
if
a
the
small
parallels are
circle route.
parallel as well.
But if I was flying to I'm on the 45th parallel in say North Carolina or north of that probably, and flying to a destination on the other side of the continent that's also on the same parallel, I wouldn't fly that parallel. I would fly a great circle. It'd be a different heading than due west, say. You know what I mean? Because the parallels are not great circles, so
All
you're
right.
not going to fly parallels.
Okay, let's just stick to the Coriolis effect, Jake.
I didn't
You
hear
guys
you,
gave Jake
Jeremy.
a chance to escape. Oh, can you hear me now?
There's nothing to escape from. You're funny, Jeremy.
Okay.
Left lane, are you left lane? Are you an
Say
ATP? Are you an ATP like me?
I'm a private pilot, yeah.
Oh, a private pilot. Okay, never mind.
okay, Jake, he's saying that pilots are not turning left or right to account for the Coriolis effect during their flight. Is that true or false?
Well, the Coriolis effect would manifest itself in the air, in terms of the inertia of
Bro,
the
true
plane
or false, bro?
in relation to its air mass.
Okay, true or false? Are pilots turning consciously or subconsciously, or unbeknownst to them, do they have to turn left or right to adjust for the Coriolis effect?
Well, again, are we talking about turning in relation to the air mass, or are we talking about turning in relation to the ground?
Talking about turning the plane.
Yeah, but are we talking about turning in relation to the air mass or turning in relation to the ground?
I don't
Because
know. Let's start over. Let's start over. Let's start over.
I don't think that there's a simple
You
answer.
have an
Because
object. No, there is a simple answer, and I'm going to get it out of you. Don't worry. Just sit tight. You have a situation where let's say we have a merry-go-round, right? and the merry-go-round is spinning and you're in the center and you want to hit a target, there's a dot on the outside edge, right? You're in the center, you want to hit that dot. If you fly off, if you start moving, aiming at the dot, right? Say you got a drone. Say you got a drone hovering in the center of the merry-go-round. If you have a dot on the edge of the merry-go-round and you fly heading towards the dot, always heading towards the dot, do you have to turn left or right in order to keep that heading?
Yeah, you would be turning.
You have to turn left or right, otherwise you won't hit the
Otherwise, you wouldn't hit it. No,
dot, right? If I just take off,
that's right.
yeah, okay. So when you're flying a plane and you take off and you're heading at the airport, if you don't turn, are you going to hit the airport?
Well, what's important is the airplane is flying in the air mass, and the air mass is moving with the surface of the Earth. And so, as
Okay,
that
but
air
we still
mass, as the tangential
have the
velocity goes
Coriolis
up, the air,
effect.
the tangential velocity.
My bad. Can you guys hear me?
Let's try again.
You guys hear me now?
Yeah, you're good.
Hello? Yeah.
Yeah, we
Whether
hear
you're
you,
turning
Jeremy.
in the air mass, right? Whether you're turning in the air or the ground's moving with the air, you still have the Coriolis effect, which means you're still going to have this effect of things are just like the bullet. If the bullet takes off, even though the bullet's in the air mass, it just goes in a straight line. And if it doesn't turn left or right, you know what I'm saying? If you shoot at where the target's going to be, you're not going to hit it. It would have to turn left or right if you were going to shoot at the target and try to still hit the target, right? Even in the air mass, even though the air is rotating with the Earth.
Okay, so here's the difference, though, right? When we talk about something like a bullet, like a ballistic projectile, its inertial forces, because of its high weight to low drag, the inertial forces far exceeds the aerodynamic forces. But the inverse is true for an airplane. The aerodynamic forces far exceed its inertial forces, right? So, for example, if you have a strong wind and you throw a paper airplane, it will immediately turn in the direction of the wind, right? Whereas if you
Right,
throw a
bro.
rock, the rock will only be slightly deviated by the wind, but it will more or less fly straight, right? But if you throw a paper
This
airplane,
is
literally the
totally
second
off.
it leaves your hand,
Well,
it's going to turn. And
so
when
you're
we're
saying it's
talking
going to
about an
spiral?
airplane,
It's
if
going
we're
to
talking
spiral
about an
when you
air,
take.
Spiraling.
if we're
It's going to
talking
spiral.
about an
The vector is going to spiral. Okay, thanks.
okay, I don't get to finish. I get it. I see how it is.
You're just totally off topic. It's not, none of that's relevant. I mean, you can carry on with the irrelevance, but go ahead.
I mean, there's really nowhere to go.
Well, that had nothing to
I
do
can't
with the
even finish
choreo.
my thought. It absolutely does,
I
because
mean, you
if you
can
think
go
about
Well,
ahead.
if it
Can you
keeps
make it
spiraling,
relevant though?
it actually doesn't finish if you
Hold
keep
on,
turning.
snacks,
I'm sorry.
snacks.
do I get to talk or no? Just let me know when I can go.
Finish your irrelevant point. Yeah, go ahead.
Well, if we talk about an airplane, an imaginary airplane takes off from the north or south pole and starts flying in a straight line towards the equator, right? You're starting where the tangential velocity is zero and the tangential velocity of the air mass is zero, right? Whereas once it gets to the equator, right, you've got an air mass and a tangential velocity of the surface at 1,000 miles per hour, right? Which over the speed that an airplane flies at, that's going to be like what, roughly 10 hours, 10 hours of flight time, right? To, airplane fly 500 miles an hour, 10, 11 hours, right? So we're only talking about, it's only gaining the acceleration that it would have to be gaining in terms of tangential velocity would be in the ballpark of 1 mile per hour per minute. But at the same time, it's flying in an air mass that's also at that velocity. So it's going to be imparting a sideways deflection on the side of the airplane, which has a big cross-sectional area airplanes, that's why they can get thrown around so much in a crosswind, right? Of 1 mile per hour per minute, where if a plane is landing in gusty winds, that airplane could accelerate by 10 miles per hour in just a few
Oh my
seconds
goodness.
from the crosswind. So to
Have you
try
ever
and
learned
to
how
Oh
to
try
my
and
land
God,
a
save,
dude.
plane?
Yeah,
Have
I've
you ever
seen
learned how to
helicopter
land a
before.
plane?
Sorry.
This
Dude,
is
hold
fucking
on,
just
man. Can I just
filibuster.
what do you mean?
Yeah, I interrupted you earlier because you were going to finish the point. So, but then we let you finish the point, I think.
I mean, you guys have never seen a gust just suddenly throw an airplane off the center line within a split
Yeah,
second?
Jake, you told us earlier. You told us earlier that the reason why the plane can hit the target is because it can turn. You're telling me a plane can take off, fly into an airport, always be pointing at the airport, never turn left or right, and still hit the airport? Is that what you're saying now?
What I'm
My
saying,
citation is in chat.
Hold on, left lane. Jesus, Jake, is that what you're saying now? That left lane tried to ruin it?
well, if an airplane has to have some tiny amount of trim to compensate for the fact that what it's experiencing as it's changing in latitude over this 1 mile per hour per minute change in the air mass. How much trim is that? Is that even one click of trim? Like I don't even know. I don't even think so.
No, you
I
couldn't
guess
measure it. You can't
Hold
even
on,
if you were
man.
trying to
Left
measure
lane,
it,
you
you
had your
couldn't
chance,
measure it.
bro. Hold on, dude. Hold on. So, Jake, you're saying you're saying we could actually take off with a plane, fly it towards an airport, not turn left or right, and still hit the airport? Are you saying that now or no? Because you gave us the reason
that's
earlier
what
you told us earlier the reason why the plane could hit the target is because it could turn.
right.
Right. So, but are you saying now it doesn't need to turn and it can still hit the target? Because it feels like you're arguing against me, and my argument is it has to turn left or right to hit the target.
I mean, I think if we're talking about in the minutia, I think it does have to turn.
It
So
does have
read
to turn.
read
Thank
the
you, Jake.
citation
Thank
in
you very
chat.
much, Jake. I appreciate you being honest. Thank you.
Read the citation
It's
in chat from
Coriolis.
the ALPA.
It's Coriolis basic. It's just a fact of Coriolis. You can't get away from having to turn there.
Read the citation.
You literally can't steel man Coriolis.
Read the citation.
I'm not gonna. Why don't you read it out loud? Go ahead. I'm busy.
These are the definitions set forth by aviation, Jeremy. They're not just my words. These are
Okay,
facts
read it.
in reality.
Go ahead and read it. Read it to us. I'm busy at work.
In aviation, crabbing is not considered turning. Big old bump. In aviation, it is a technique used to maintain the aircraft's longitudinal axis along a track. Blah, blah, blah. So it says exactly what I said. And then they even referred to the side slip I was mentioning. That's also, they call it that as well. But it's crabbing. It is not turning.
Okay. Well, then that's not the thing you're doing. Then that's not the thing you're doing to adjust for the Coriolis effect. Because, like Jake just said, like I've been telling you, like everyone knows about the Coriolis effect, you have to turn. Otherwise, you will not hit your target. The bullet won't hit the target. The plane
It's
won't hit the.
unbelievable. It's
It's
unbelievable, man.
unbelievable that you're arguing this and don't know anything about it. I know it is. I feel embarrassed for you right now.
All right, Daiso with the soundboards.
Man, that was timely.
That was timed.
That's not bad either.
For some reason, the soundboard's really loud for me, though. It's like extra loud. That's often why I don't do them. I don't want to blow people's eardrums out where they're like, what is that? Left lane, if you're driving, do you want me to read this thing or do you feel like you read enough of it that you wanted read?
Yeah, you can read the whole thing. And I do not need to be reading and driving.
Well, is this kind of the thing you guys were talking about? Jake said it earlier. If you're on one side of a river and there's the other side of the river, and you need to get to that other side of the river, it's a straight line from you. You're on the one side of the river. There's a target on the other side on the opposite side of the river. The water's rushing. Let's say from right to left. You're looking at the target from right to left. The water's rushing, and it's a straight line from you to that target, though, like straight path. If you were to get in a boat, you would then have to get in the boat, and you would have to kind of keep turning your wheel to the right basically, as you're traveling to counteract the right to left rushing water. You have to keep kind of turning your rudder, your whatever it is in your your propeller in your boat to be to continue that straight path. But even though you're turning your wheel, you're just counteracting the water, but you are actually making a straight path. Does that link to anything you guys? Does that link to what you guys are talking about?
It's kind of the same thing. The thing is,
No,
when
it's
you
not
get
the
your
same thing.
thrust vector set that exactly counteracts the current or the crosswind, you're not still turning. You actually, you're just going to hold that position, and it's not like turning the aircraft. You're just going to direct the thrust into the direction of the force to compensate and maintain a heading.
No, Gio, the boat thing has nothing to do with it. There's not two frames there. There's an actual force pushing you there. When you have the Coriolis effect, there's no force pushing you there. There's two frames. Like there's only one frame there. You know what I'm saying? You're either turning or not turning. You can't draw the inertial and the non-inertial frame. The Coriolis effect, it's literally physically impossible to do what Left Lane's saying. Jake even admitted it 5 minutes ago. You have to turn. If you don't turn, you will not hit the airport. You cannot steelman Coriolis. Just straight up, you can't steelman Coriolis. You can't do it. Jake can do it. He just did it. Anyone can try this. If anyone has any spinny thing, spin something slow, but before you start spinning it, draw a straight line on it. Now try to move your finger over the straight line without turning your finger while it's spinning. Can't do it because the Coriolis effect is at play, and that's how it works. It's impossible to do what you're saying. Like I don't think you understand.
Except I do it all the time.
It's impossible. You'd never do this because you'd be going against the core. You're saying the Coriolis effect is wrong. You're saying the Coriolis effect is wrong? Or there is no Coriolis effect. Maybe that's what you're saying. That's the only way. Does anyone have some spinny thing? Like if this is like a question in anyone's mind right now, get a little spinny thing. Get a paper plate and draw a straight line on it with a magic marker and spin it slowly in front of you with one hand. Use the other hand to try to stay over the line, that straight line. You won't do it. You can't do it. You can test this for yourself right now with a paper plate and a magic marker. The thing Left Lane says he does every day is literally physically impossible when you have the Coriolis effect.
Well, I think what we're missing here, though, Jeremy, if we start with like imagine a spinning globe, and then a car, or let's use your example of the merry-go-round, right? Because that one's I can think a little easier. If we imagine a merry-go-round and we paint a little road on the merry-go-round that's straight.
You got a merry-go-round. You want to hit a dot on the edge of the merry-go-round. You're hovering in the middle. Go ahead.
Okay, but let me just start. If we start with a car that has like really slippery wheels, and then we push it forward, right? Then the inertial forces of the car will be stronger than the friction between the wheels and the merry-go-round, and so it will deflect and it won't arrive at where you want it to arrive, right? But if we have very sticky wheels, right, or if we had like Velcro wheels, then the car would arrive on the other side, right? Because the tangential velocity would be transmitted. You know, the force of the tangential velocity change would be transmitted. You know, to the vehicle, right? Because it's basically grabbed onto the car, right? And so in an
So are
airplane,
you arguing? Are you trying to argue for left lane now that you don't have to turn the plane? You
and
just told me you did have to turn the plane.
well, here's my whole point is the airplane is not obviously tied, tied to the air mass the way that a car with Velcro wheels would be tied to the surface, right? But it is viscously coupled to some degree with the air mass. The question is, to what degree is it in comparison to the change in inertial forces versus aerodynamic forces? And because we're talking
It
about
doesn't matter, dude. You have the Coriolis effect.
such a slow change, then essentially the aerodynamic forces could be viscously coupled with the airplane, in which case there would essentially have to be no turning at all in the airplane.
No,
In the same
dude.
way
If
that you wouldn't have to turn,
Oh
in the
man,
same way
you
you
still
wouldn't have to
going?
turn the car, in the same way that you wouldn't have to turn the car with the Velcro wheels, right? Because it's coupled to the surface.
No, dude. We're talking about the Coriolis effect, right? I just gave everyone a little example with a paper plate and a magic marker that everyone could go try right now. The thing you're saying now or not saying before, I don't know. It sounded like you said they would have to turn the plane. Now you're saying they don't. I don't think you know what's going on at this point. The fact is, these are basic Coriolis physics facts. If you don't turn the plane or your finger over the paper plate or whatever object you're doing to trying to hit the thing, if you take off aiming at the thing, you will never get to the thing. That's just the Coriolis fact. There's no way around it. You're saying all of Coriolis physics is wrong by saying this. I don't care what left lane's flight manual says about crabbing. This is the Coriolis effect, and if you have it, you have it. And if you have it, you can't do the thing that left lane's saying he does every day. Go get a paper plate. Try it, dude. Oh my God. Did you guys hear any of that?
Yeah, the Coriolis effect, though, a whole lot depends on speed. So if you're traveling at 8,000 miles an hour going straight north, you'll experience tremendous more effect from the Coriolis effect than if you're in a Cessna traveling 120 miles an hour.
Yep, the speed will make a difference. Sure, you still have to turn either way, though.
Yeah,
No
because
matter how fast or
like I
slow you're
said,
going, no matter how fast or slow you're going, you're still going to have to turn to hit your target if you take off aiming at it. So, like
what
I
about
said,
a car?
anyone can try this at their house right now with the Coriolis effect. This is always the case with Coriolis effect. You have to turn, or you will not hit the thing.
Yes,
What
but
about the car with sticky wheels? What if we have a really sticky
Yeah, if
surface
you're on a Velcro
merry-go-round and a car with
merry-go-round,
sticky wheels and it's driving from one side to the other? Does it have to take into account the fact that the merry-go-round is turning, or will it be as if it's not even turning?
I don't know. Is it have the Coriolis effect on it? Then it has to turn.
well, what if you were in a Velcro suit, right?
Imagine if you had Velcro wheels.
well, what I'm saying is, if you're at 300 to 400 miles an hour or less, the Coriolis effect is so small that you don't even have to worry about it.
It's not true.
Compared to the size, yes, it is true. Compared to the
You
size of the
still have
planet,
to turn.
That's not true.
Okay, but you still have to turn though.
it's dependent on
football
speed.
games.
It's entirely dependent on speed. And no, when you kick a field goal, the Coriolis effect doesn't affect the ball. It's entirely dependent on speed. It is so. If you're traveling less than 500 miles per hour, it is so small that it's basically non-existent compared to the size of the globe that you're traveling on. It's only when you start going really fast. I don't care what Neil deGrasse Tyson said. So many people has shown that Neil deGrasse Tyson made a stupid comment that day.
Okay, it's not even relevant though. The point is, it's not even relevant. The point is, you have to turn. You have to turn. You'll never hit the thing. I don't know what the sticky wheels thing is or whatever, Jake. But if you're affected by the Coriolis effect and you don't turn, you won't hit the target, just like the bullet.
Laces out.
Laces out, Finley. What was the name?
So let me ask you this,
Well,
Jeremy.
what
If
if
I
the
have a
plane had
lazy,
like footy pajamas, you know, with the
if I have
feet
a
built in?
lazy Susan, if I have a lazy Susan that's slowly spinning, and then I push my Hot Wheels across it, will the Hot Wheels end up directly across where it was as if it was stationary, or will it because obviously it can't turn, right? Or will it still hit the opposite side of the lazy Susan regardless if it's turning or not?
Dude, I don't know, but can we stick to something in the air?
I think this is
I don't know
important
All
what
though
right,
the
we
because
I
got
don't know what the car is gonna
we're
do.
talking about the
If we,
we got
relationship between we're talking about the relationship between
Yeah,
Velcro
what kind of
wings on
toys
the
can we
plane.
use to talk about air, Jake?
I mean, dude, you guys just
Velcro
aren't
wings.
stalemate the globe. You spent the last 5 years telling us that you had
Jeremy,
pilots
calm
had to
down.
turn.
Don't
You
don't let
spent
this
the
get the
last
hold of
five
you,
years.
dude.
No, you're right. You're right. You spent the
You're in a
last five
classroom for
years.
crying out loud, bro.
Hold on, man. All right, everyone, stop interrupting me, and I'll try to keep my cool. Okay. You guys spent the last 5 years telling us pilots do adjust for the Coriolis effect. It's just so small they don't know. That adjustment is a turn. There's no other Coriolis adjustment you would do other than turning left or right because that's what keeps you on the path. If you don't turn left or right, after a while, you're not even facing the airport anymore because the Coriolis effect. Unless you're saying there is no Coriolis effect, which is what it almost sounds like you're saying. You're saying
What you
no, there
run
is no
Hit him with the
Coriolis effect.
Velcro wings,
what you run into, Jeremy, is the natural adjustments that you make from wind shear, from just naturally the natural adjustments that you have to make when you fly a plane is greater than any adjustment you have to make due to Coriolis
I
at the
know.
speed you travel. So that's why it
I
doesn't
know.
matter. It's
No, it does
only at
matter
high
because
speeds that it matters.
but the argument is they're not doing it. But the real what the real globe says is that they are doing it. They just don't know because it's so minute. In fact, they spent the last 5 years telling us that. Okay, Cole? Jake probably told me 17 times about that.
Yeah, now he's on Velcro wings, and it's the whole arc, and then we're at Velcro wings now. This is
Yeah, I'm
amazing.
not getting in on Velcro wings. I don't know what that's about.
It's yours. You own it now.
I don't know about some Velcro wings.
If there's anyone unsure of what I'm saying, is Jeremy a nutcase? Is he telling the truth here? Does he know what he's talking about? Get a paper plate.
I'm definitely questioning that.
Get a paper plate and a magic marker. Draw a straight line from the center to the edge. Okay. Now try to stay on that line without turning. You can't do it. And if the end of the line was the edge where your airport is, you're not going to be on your airport if you don't turn your finger left or right as you move it over the paper plate.
How fast are you turning the plate?
You could turn it as slow or as fast as you want. It doesn't matter. You have the Coriolis effect and you're going to have to turn. No matter how fast or slow it turns or how fast or slow your finger goes, if you have the Coriolis effect, this is just a fact.
Here's a question for the Globers in general. Would it be more like, so you know these really high, like fast moving blackbirds, like the ones that sort of, you know, Air Force and whatnot? Would that be more or less subject to this Coriolis force? Because I kind of get where you're coming from in the
More.
viscosity of the air. So
Be
yeah,
more.
it'd be more prone to it. Okay.
Yo, bro, Coriolis don't care about viscosity. What the hell does that even mean?
They're just trying to
I don't think that's
basically
What the hell does that even mean?
well.
they're trying
If
they're
you
trying to hide it.
if you think of viscosity as the railroads of a train, right? It keeps the train moving on that path regardless on any forces perpendicular to the train movement. So I think that's the kind of what the point is.
Sorry,
Bacon
they're
don't even
claiming
know what you guys are talking about. Bacon tried to
they're
use
claiming
train
100
tracks, bro.
I don't think it's exactly the same. I'm just trying to explain what I think the argument is when viscosity is brought into place. I don't think that's a good argument, but I don't think Hey, I'm just trying to explain what the argument is.
I'm sure they appreciate you trying to help them out, Bacon. They're in too deep, though.
Yeah, I don't think
Bacon knows what I'm saying. Bacon knows what I'm saying is true. How long you been here for, Bacon?
I don't know what you're saying, actually. Do you want to lead?
Well, they were doing like kind of a tag team wrestling thing, and then you're in here off the top ropes trying to defend them. So do a good job, I guess. Jimmy's super fly snooker kind of like over the top.
Bacon, if you have a plane, right? You're about to fly a plane over the rotating globe Earth. Okay.
Yep.
And we're going to take off flying we're going to be aiming at the airport, going straight at it. If I don't turn left, let's just say there's no wind for this, just so we don't have to deal with wind. There's no wind. If I don't turn left or right, If I don't turn left or right, will I hit the airport?
Yeah, assuming like perfection in all those other things, all those variables, then no.
You won't hit the airport, right? Because you would have to turn because Coriolis is throwing you off your path, just like the bullet.
Yeah,
No, of course.
Assuming zero wind, assuming the airplane engines are working perfectly symmetrically, all the aerodynamic forces are symmetrical.
Yeah, we're not worried about. Yeah. Not even worried about the other. We're just worried about the Coriolis thing.
Yeah, but we're not worrying about real life stuff. That's the problem.
I
know, but I'm just trying to show these guys. I know, but I'm just trying to show these guys that if you don't turn for the Coriolis, you're not going to hit the target. I realize there's other things you might have to adjust for, but obviously, if you don't turn, you're not going to hit your target for the Coriolis.
Well, I'm not sure turning you're gonna have to do something. If you just fly as you would fly to go perfectly straight with no wind, and we add a force like Coriolis, then that's going to change your path if you don't do anything about it, obviously.
I could do it to where you don't have to turn. There's a certain way though.
With the Velcro?
Yeah, turning might not be the right term. An airplane doesn't have like two buttons, turn left and turn right.
Well, no, you were right initially.
It flies,
but there's a way you could do it without
the way
turning.
It flies, I'm pretty sure you could hear me speaking. The way you fly an airplane is more complicated than that, right? But anyway,
just fly straight where it would be, not where it is. Get them dice low.
Yeah, exactly. You would lead the target instead of following it, and typically they follow it. And the only way to lead the target is to know where the target's going to be, right? Accounting for Coriolis effect before you ever leave set flight.
Yeah, that's my argument. But they're not doing that. They're flying at where the airport is.
Right.
So they're not doing that thing. They're doing other thing. And when you fly where the airport is, there's no way to get there unless you adjust
leading
the
the target is not the way
effect.
you counter Coriolis.
That's the way you get there, by not turning left or right, though.
Well, only in the scenario that we just came up with, which is totally unrealistic, right? Where there's no wind, there's none of that. Like if there is wind, if there is anything,
yeah, it was just a hypothetical.
If the left engine is slightly.
It was just a hypothetical to show that you would have to adjust for the Coriolis effect, obviously.
Yeah, in that hypothetical, that doesn't really match real life scenarios.
Okay, so you're saying, are you saying in reality we don't have to turn left or right, and you can take off flying at an airport and not?
That's not what I said at all.
Okay, so you're saying we would have to turn left or right.
You do have to.
Are you saying we would have to turn left or right and adjust for the Coriolis effect?
How about you let me say what I want to say instead of?
Well, I'm just trying to get like a clear cut answer out of you, and it seems like you're like fighting it
first, and then you try to interpret it, right?
No, I just want to get a clear cut. I'm not trying to interpret anything. Just give a clear answer, and there won't be anything to interpret.
Yeah, if you don't interrupt me, I might give you an answer. What I am saying is that you're gonna have to turn left and right and do all sorts of stuff with an airplane, even if there was no Coriolis.
So it's the Kentucky windage of it.
We know.
That's not the fucking point, bro. Yeah, he's appealing to all these other things like the complexity of flying a plane, the wind,
real life,
this, that, the other.
Windage.
Yeah, I understand, but that's not what's in contention. Dude, you're trying to wiggle your way out of facing the facts, is what you're doing.
It's not that
when
complicated.
I'm conceding to the scenario where there is no wind, there is no any slight variable that you would do anything with the plane except Coriolis, then obviously I already agreed you would have to do something to reach the airplane. Sorry, to reach the airport.
Well, we
You'd
weren't
have to-
asking for something. We were very specific, turning or not.
Yeah, turning. I'm not sure how planes work. If you want to go left, how do you turn? Like there is no
What do
turning
you mean?
button.
Change of direction. What do you mean?
It's
Like,
not a
Stick
button.
over, then you
Yeah, it's
pull
not a
back.
button. It's a yoke. It's a yoke, and
Yeah,
you would
but
just
you don't
turn
just
the
turn like you
yoke.
tilt the plane and yeah, your altitude changes when you're taking a curve. Like all sorts of things change, not just in which
Okay,
horizontal
but
direction
okay.
you're pointing.
All right, let
That's
me
what
ask
I'm
you
saying.
another question. All right, Bacon, let me ask you another question. In the when you have the Coriolis effect, right? Let's say we just have some simple example of now, because you're going to say something stupid like Jake said with the. Let me use the bullet. Let me use the bullet. We shoot the bullet at where the target's going to be, right?
That doesn't work. That's not how you account for Coriolis.
Oh, you shoot the bullet at where the target is now?
That's also not how you account for Coriolis. Don't
So
assume what I
do
think.
you shoot the target at the bullet or not at the bullet? That is a true dichotomy.
Oh, neither. Those are not the no. Not at the bullet doesn't mean where the bullet's going to be. Sorry, not at the target. That's not the same thing as where the target's going to be. Like if you're in a moving train, straight line, no Coriolis, no pseudo forces. You point where you see the thing. You don't point where it's going to be because that's not where it's going to be.
Okay, so the
If the train's
Coriolis
moving.
correction. Okay, so you're telling me a Coriolis correction would be I'm still shooting at where the target is, where I see
No.
it?
Yeah.
Okay, so a Coriolis correction is you shoot where the target isn't.
Neither.
Right.
Yo, you guys,
Neither.
are you guys fucking high or something? Come
No,
on.
that's
No.
right.
he's
That's
all
right.
over the place. He's
No, when
contradicting
you're
right.
himself.
when you're flying an airplane,
Yeah,
you got a
I'm not
heading.
cool. I'm saying yes. I'm saying yes to your
when,
question. If
when you're flying
you're shooting where it isn't.
when you're flying an
That's right.
airplane, you got
That's
a
not the same
heading.
thing as you shoot where it's going to be. Cole, let me argue here. If you think something else, then we have two different arguments. Let me make my
But you're
own point first.
go ahead.
Right. Yeah. Yeah. Of course, if you're not hitting where you see it, then sorry. If you're not aiming at where it is, then of course you're aiming where it isn't. That's not the same thing as aiming where it's going to be.
Okay, but you're aiming so that the bullet will be
5 or 6 days in Reno.
Hold on, somebody's hot micing. Are they trying to get in or hot micing?
That's
I think that's
Andrew. Yeah, go
Andrew
ahead. If he hot mics
flirting
again.
with somebody. I'll move him.
I'm just saying, if you're going to talk about Coriolis, you can't talk about it like you're shooting something out of a bullet. You talk about it, you got all it does is express itself
you
as
can.
a drift from your heading. No, you got a heading, and as you're going, the Coriolis will express itself as a drift from that heading, and you just constantly correct yourself to stay on the proper heading. All Coriolis will make you do is drift from that heading, and you constantly correct on that heading. That's it.
The correction is you turning back
Is
left
turning.
or right to get back on the heading. Okay,
Exactly.
Cole, you're on my side. Welcome to the party, pal. Bruce Willis, diehard. You're on my side,
To
Cole.
that too.
Cole, you're okay. So you, Cole, Bacon, and me are all on the same side against left lane. You guys get them, okay? I got work to do.
Left lane's a pilot. Damn, I can't argue against the pilot.
Wow, it's appeal to authority right out the gate. You guys aren't on my side. You guys are off the team.
Okay, so let is left lane still here?
Yeah, well, we've already talked about it in depth.
Oh, do you disagree with what me and Cole are saying? Because Jeremy says you are.
No, I just say I make the correction, and we call it crabbing. I'll point my thrust vector into the force to accommodate it and fly a straight path across the ground.
Yeah, now left lane saying he doesn't have to turn. Remember how you said you do have to turn?
Hang on. If turning is just changing direction, then part of crabbing is turning, right?
No, crabbing is just adjusting your thrust vector to accommodate a crosswind. Turning would be changing in the heading, your track across the ground. You don't turn if you're not changing your heading.
Wait, hang on. What is
left
crabbing
lane said
exactly?
He said he's not turning, Bacon.
So if I've got a right crosswind, I'm going to use a little right rudder and point my nose into that wind a little bit to maintain my heading across the ground. To turn indicates a change in direction, a change in heading. If you're not changing your heading, you're not turning.
Oh, hang on. So heading is where the airplane is moving, not where it's pointing at?
That's correct.
Ah, okay, okay. So turning is when you change the direction in which it's moving, not in which direction it's pointing at?
Yes, a turn would indicate a change in direction. You know, the ATC will say turn to a heading of 90. Well, your magnetic compass may say 110 for you to go on a 90 heading.
You know what?
Right.
You know
Yeah.
what
So
drifting
this
is
is
making
just
in a car? Do you know what drifting is in a car? That's crabbing in an airplane.
right. Got
If
it.
you know what drifting is in a
Yeah, yeah.
car,
So again,
okay,
like
that's
I don't
crabbing in
think
an
the
airplane.
disagreement here. I don't think the disagreement here is related to Coriolis. I think it's just what words we're using to describe the motion of the plane.
It's kind of like eating ain't cheating.
Yeah, I'm saying you have to turn the plane because if you don't make a turn, whatever you want to call it, adjust left or right, change your direction left or right. If you
Yeah, we have
don't
to
do
do
that,
adjustments. If
you have to adjust left or right. Yes, I know.
it's not,
That's called a turn. Whether left lane wants to call it a turn or
no,
not, you
it's
have to
not.
turn.
Yeah, apparently in aviation you don't call it a turn if you're just changing the where the plane is pointing at. If you have to also change the heading, right?
Okay, so he's not turning in aviation terms. However, in real life terms, if you don't turn
That
and
is a
there's
real.
Coriolis there, if you don't turn and there's Coriolis there, you won't hit your target. What
Right.
you
Yeah.
could do is
If you
play.
don't do nothing about it, of course, if you just fly as if there was no wind or anything, then yes, you're going to deviate from the path of the target.
Yeah,
Let me
left
ask
lane
you a
just doesn't
question.
want
Let
to
me ask you
call
a
it.
question, left lane. If you are in a heading of say, what was it? You said 10, right? 10? Is that what you said?
Just what?
In
Yeah,
your
no,
example?
110. 110 is my
110.
example, or whatever. Whatever your track across the ground is what you're trying to maintain, and
Right.
your
So,
your compass may read 10 or 20 degrees off of that depending on the crosswind.
okay. So let's say they ask you to put your compass heading to 225. Do you have to turn to head that direction?
They don't tell you a compass heading; they just tell you a
No,
direction.
they'd say that to head to 225 instead of 110. In other words, you have to turn to put your heading towards 225.
Yeah,
Okay. So
Yeah,
when
that's how we
you
describe that turn.
right, but it's still a heading of 225, but you have to turn from 110 to 225 to be able to head that direction.
sure.
Okay, now imagine you're going towards 225 now, and a wind
Okay, so
is
it's just so.
constantly blowing you to the left. So if you crab to the right, you'll continue to go straight towards 225, even though the nose of your plane is not pointing towards 225. It's pointed a little bit off, but that's because the wind is constantly trying to blow you off of it, and you can point your nose slightly into the wind and crab the whole time, and you'll continue to go towards 225, even though the nose of your plane is pointing a little off from it.
Okay,
It's like
great.
going across a river on a boat.
Okay,
Go
great.
ahead.
So the whole left lane thing was just a word game.
Coriolis, though, isn't it?
In reality, the whole left lane thing was just a word game, and uh, he is actually turning the plane. Whether they don't call it that in avionics is irrelevant. The plane is physically changing direction. You have to change direction, otherwise you will not get to your airport.
Well, changing
You literally
direction
have
and
to
the
change
changing
direction.
the
Yeah, changing direction of
changing
the
the
plane.
direction.
Yeah, that's right.
Yeah, changing the direction you're
Yeah,
flying
it's
and
a
the
turn.
changing the direction you're pointing is two completely different things, though.
Yeah, we're
Yeah,
just talking
exactly.
about turning the plane this whole time. So obviously you'd be turning the plane, changing directions of the plane. Yes.
Yeah, then
Because
yeah.
it's
Then
just
we
like
all
if
agree. Okay.
It's just like if you're trying to take a boat straight across the river, you would have to point. You don't point straight across the river. You'd have to point the nose of the boat upstream, but you'll still go straight across the river. That's why I said turning the plane and turning in the air and the direction you're flying is two different things. You can turn your plane without turning the direction you're flying.
But the Coriolis and what the wind is doing to your plane is two different things.
No, the Coriolis manifests as a crosswind.
No, that's not.
Stop that. It's what gives the Jedi his powers.
Saying they are the same thing and saying
Stop that.
they're manifest as the same thing, those aren't the same thing, right?
He just said it just manifests as a crosswind. Left lane.
Yeah,
that's a load of a story. No, it does not affect as a crosswind.
What would be the difference?
A crosswind is a crosswind. Coriolis is a change of where the location of you're heading, the location you took off to changes.
No, that's not what Coriolis is.
Yeah, I didn't say it was a crosswind.
Hold on. He just said something. Okay, how are you going to respond when he just responded?
You're going to continue to straw man.
Wait.
Go ahead.
You just said that the location that you went off to did not move?
That's not what I said. I said that's all Coriolis is.
So are you saying which one is not a Coriolis? The wind, the crosswind, or the place moving?
A moving place is not Coriolis. A train. Hang on. Let me just elaborate on that sentence. If you're in a moving train and you're trying to hit something that is also in the moving train, there is no Coriolis, and the train is moving. So the fact that the thing you're trying to hit is moving,
it's not Coriolis then.
Coriolis there. Exactly, that's the whole point.
Okay, well, I'm saying that once something leaves off the ground, but your floor is rotating, but you're heading in one direction, and the place is constantly moving, right?
It's still not Coriolis.
What are you talking about?
Because you can do
the ground beneath you has to be continuously moving while you leave the ground.
You don't have to shout. If you ask me what the hell I'm talking about, then let me tell you what the hell I'm talking about.
Just settle down, Elbow. Settle down.
What you just described matches a movie.
Yeah, it's weird how he could just say some weird stuff. Go ahead. I'm sorry, I interrupted.
Yeah, no problem. What you just described, we can do in a moving train. There is still no Coriolis there.
So as a moving train, it's completely a red herring. Well, I'm talking about a rotating ground underneath you. Where you left is rotating. Correct?
Yeah.
Right? Yes. The plane, that's not, so the plane left the ground. The earth is still rotating. The plane is going one direction while the earth is still rotating under him. That means the place where he was headed to changed location.
Right,
means he has to adjust because he's not on the ground, he's off the ground.
But you're still rotating with the earth. It's a change.
So no Coriolis then.
Oh, no. It's a change of tangential speed underneath you.
Hang on. Yeah,
don't interrupt Elbow. Elbow was right. Elbow was completely right, by the way. I'm resisting getting in this conversation. Don't interrupt Elbow. The reason they talk about conserved momentum is because they have to talk about conserved momentum because it's rotating separately. But if you change your tangential gradient, because of the tangential gradient, you would never be in sync. That's why they have to talk about conserved momentum. I'm sick, so I can't talk. But don't let them conflate changing direction and to catch up to where you're supposed to go with the winds. Just take the path away. A joyriding pilot can fly wherever he wants, land wherever he wants.
Yes, he can. Hey, what's your point? But anyway,
yeah, the point is he's not following a ground path.
Hold on.
No, you're asking me what my point is, and I'm going to say it and leave. I'm leaving.
You stated it.
I'm about to leave,
right.
okay?
Okay, goodbye.
The point is, he doesn't need a ground path. He can land at a higher tangential velocity.
You just said
that. Actually, he can't. He would never be able to. The conserved momentum doesn't match
ground path is what we fly.
Yeah, when you leave the ground,
everybody just chill. Hold on, Cole. Hold on for a second. New Perspective said he's sick. He only has a minute. He did kind of come in the middle of them, but Bacon was maybe on his point. Can we just let New Perspective say his full point without all these interruptions? Just let him go for a minute.
Elbow's doing fine. I just wanted to make sure people weren't interrupting him. It's not the same reference frame. They claim it's a separate reference frame. That's why they have to claim conserved momentum, because it's a separate reference frame. That's why they have to say there's conserved momentum, right? So if you go to a different tangential velocity, you're not going to have that same momentum. And you don't have to have a ground path. They rely on that to say, oh, I'm on the ground path, so I must be moving at the same speed as the ground. No, you would not be moving eastward at the same speed. When you land, the Earth isn't going to stop rotating to make sure you could slow down to land on a stationary surface, which is how they're taught to treat it. The surface would never be stationary, right?
That's right.
Your plane's not going. If you're going west
Okay, how
southwest
long is your
and
point going to
aiming west,
take?
I'm about to leave. When you're aiming west and you're flying west southwest, you can't have the plane moving backwards with the rotation of the Earth, so the pilot can treat it as stationary. That's it. It's over. There's no way for the Earth to stop moving so you can treat it as stationary. No way. The Earth keeps moving at a higher tangential velocity than the one you took off from. It's over.
Exactly. That's called Coriolis. That's what you correct for.
Why the hell? He wanted to like interrupt the conversation because you and me were both trying to answer Elbow, and then he cut the conversation for like 2 minutes, and then he drops. Like we can't even respond to him. So why the hell would he do that?
Well, I don't know. He said he's sick. He only had a minute.
Hey,
He popped in.
it's
It is what it is. He left, so just carry on. He said his point.
Yeah. Well,
it was kind of Chris Farley-esque a little bit.
Yeah.
Well, you see, he did say something that we say that we do not say. The atmosphere moves with the Earth. You're not leaving the reference frame because you're leaving the ground.
Yeah, you don't leave reference frames. Like
Dude, you're
reference
leaving the
frame is
reference
not a-
frame because you're changing. You're leaving the reference frame, the non-inertial reference frame, because you're changing your tangential speed to the rotating reference frame. That's why we know the plane is in the inertial reference frame.
No, don't get into reference frames because you guys don't know what that means. You can't leave reference
I
frames.
do know what that means.
No, you
I
don't.
do know what that
You think
means.
you
That's
can
just
leave
an
a reference
insult.
frame? That
It's
doesn't.
just an insult. You're just insulting
No,
me
that's
by
a
saying
fact.
I don't know what it is. I know implicitly what it is. It's a fact. I know implicitly what reference frames are.
You know implicitly.
Yeah, implicitly about
So you don't
reference
actually
frames.
know. You
Yes.
just know implicitly.
I know everything there is to know about them.
Oh, really? You know enough that you can tell me what the path of a bullet would be on a rotating Earth? Or not that much?
I
Maybe
mean,
not.
I can't do the math for you right now. I'm at work, but
Well, that's part of knowing.
I know that the plane is in the inertial reference frame. And
Yes, I know
the
even
other
less
reference
because
frame, is the ground underneath it, the rotating reference. There's two frames when we're talking about Coriolis effect: the inertial and the non-inertial, the rotating and the non-rotating. If everything's in the same reference frame, if the plane never leaves the non-inertial reference frame and just stays in that frame and never goes inertial into the inertial frame, there will be no Coriolis effect.
just saying leaving reference frame is already nonsensical.
It's not nonsensical. The plane is on the ground. There is no inertial reference frame. The plane's in the non-inertial reference frame. Then it's in the inertial frame. What
You
happened
can't
if it
keep
didn't
making that claim
if it didn't leave the non-inertial reference frame? How did it get in the inertial reference frame?
because it's already in the inertial and in the
It's in
non-inertial
both.
reference.
Yeah,
You
There
can't
it's
was
in
no
leave.
both.
inertial rep before the
Well,
plane
don't
started moving.
interrupt
There
me.
was
I'm
no
trying to
inertial
respond to you.
reference
You
frame.
went for like a. Okay, let me finish.
Oh,
You
I'm
can't
responding to what you
leave.
said. Go ahead.
I was responding to what you said, and I said like 3 words. Anyway, you can't leave reference frames. Reference frames aren't medium. They don't have space. They don't have a size. They don't have boundaries. They're just coordinate system. They extend infinitely. It's just a coordinate system. It's just a reference for you to locate.
You're not answering
things
my
in
question,
terms of
though.
velocities.
You're not answering my question.
I'm just educating you on what a reference frame is and
Yeah,
how
but if you're
the way you're
educating me,
using the
answer my
term
question.
and how you're using the term is just nonsensical. So
You're
your
not.
question
You're
is
not.
nonsensical.
You're not educating me. You're not answering the question.
Just did. I said it's a nonsensical question because
It's not a
reference frames
nonsensical
don't.
question.
It is once you understand what a reference frame is. Your question doesn't make any sense because you can't leave or enter a reference frame.
Okay, the plane's on the ground on the tarmac. All there is the non-inertial reference frame right now. There is no inertial reference frame, right?
That's not true.
Okay, where's the inertial reference frame? The plane's not in it. The plane's in the
Everywhere.
non-inertial reference frame.
A reference frame doesn't have a location.
Okay, what's inertial? Where is it? What is it? What's going on with it?
Well, it's a
Nothing's in the
reference frame that
inertial
doesn't have
reference frame.
acceleration.
Nothing's in the inertial reference frame because the plane's in the
Everything
non-inertial
is.
reference frame because it has the same tangential speed with the rotating reference frame. There is no inertial reference frame until the plane changes its tangential speed to the inertial reference frame. Then it goes inertial. It's in the inertial reference frame, and you have the Coriolis effect.
Everything's in all reference frames. What you're saying makes no sense.
You know what? Rumpus was in here one day, and somebody tried saying that. Rumpus said it makes no sense to even talk to you about the Coriolis effect now because everything's in every frame. There's no point in even talking about it. That's just a nonsensical statement.
There is a point.
Nonsensical statement.
No, it's not. The point of a reference frame is not to determine whether something is inside or outside of it. The point of a reference frame is to describe positions, velocities, and acceleration. And that does make sense. You can be in multiple reference frames. If you change from one to the other, that changes those values. It changes your position, velocity, and acceleration.
Okay, but before the plane takes off, though, there is no inertial reference frame. The plane's not in it. There is no Coriolis effect happening. There's no Coriolis effect. Is there Coriolis effect happening before the plane takes off?
No. Requires
no, there's not because there's no inertial reference frame because the plane hasn't changed its tangential speed yet with the ground.
False.
Which is how you get into the. That's how you get into the inertial reference frame is by changing your tangential speed with the rotating reference frame.
That's how you get Coriolis. That's not how you enter the inertial reference frame. You're already there.
Yeah, you enter it by changing your tangential speed to the non-inertial reference frame. That's how you get in the inertial reference frame.
The reference frame is just how you look at it. It's not like the plane leaves one and goes into the other. The plane's in both all the time.
There is no inertial reference frame when the plane's on the tarmac not moving. The inertial reference frame doesn't even exist.
It's just like if you roll a ball.
You guys don't know jack shit. I don't know why we even talk to you guys. You guys don't know anything about any of this shit.
It's just like if you roll
Their
a
understanding
ball.
is not implicit whatsoever.
Like you guys get everything wrong. It's crazy.
It's just like if you roll a ball across a turning plate. All right, you can look at it in one reference frame and say that the ball curved, or you can look at it in another reference frame and say it went straight. But the ball is in both reference frames all the time.
Okay, but before the plane takes off and it's just sitting on the tarmac, it's not in the inertial reference frame. There is no inertial reference frame yet, so it's not in all the frames all the time. That frame doesn't even exist yet. It's not going to exist until the plane starts to move. You guys just say shit. You guys just say stuff and get it all fucking wrong all the time. It's ridiculous.
No, Jeremy, we're not. These things are very easy concepts to understand. Just play an airplane game for a little bit. It'll teach you exactly how it all works.
Hey, the plane's in the inertial frame before the plane takes off. Explain to me how that works, Cole.
Hang on, before you go, Cole. That video
let
game.
him explain how the plane's in the inertial frame.
Yeah. Just give me 2 seconds.
No.
Is the video okay?
Yo,
sorry. Go ahead,
bro. Come on, dude.
I just said play a game because that's the easiest way to visualize the concept. It's when you're trying to visualize it in your head without some way of looking at it. Yeah, you can make a little model to do it, but that's a hell of a lot more
You're not answering my question, Cole.
Than just playing a simple airplane game that'll show you how things are. A reference frame is just depending on which way you want to look at it. You can look at it
Cole,
in
you're
one
not
way, or
answering
you
my
can look at it in
question.
another way.
You didn't answer my question, Cole.
I'm sorry. Where is
the? Yeah. Is the plane in the inertial frame while the plane's just sitting on the ground, not moving?
It would still be in both frames. It's just one is not moving. It's not moving yet, so it's not being affected.
Okay, so you're saying the plane's in the inertial frame, and that means we have the Coriolis effect happening. Because if you have something in an inertial frame and a non-inertial frame, you have the Coriolis effect.
It's not in any frame. The reference frame
So
is
the
just
plane
how we're looking at something. That's it. It's not like
things
it's a
are in frames. Things are in reference frames. Yes. If you said
reference.
on a reference frame, you get Zanuck in here. In reference frame is okay though.
Reference frame is just what humans are using to determine the path of something. It's not like
I'm just backing
it's
out. You guys don't
moves
know
out of
shit.
one and into another.
Okay, good talk, guys. Good talk. You guys don't know anything about this. I'm just gonna back out. It's just frustrating and maddening.
Well,
Yeah, and
likewise.
how long have they put an Earth curve into your video games? Your flight simulators, how many Earth curves they put in there?
Kerbal, you're on a ball all the time flying on a rotating ball at that.
You didn't. Yeah,
You're
you
not
ignored my
on a
question. You ignored my question.
you're
Thanks.
not on I'm answering you. You're not on a flat surface. You're not flying on a flat surface. It models an actual sphere. It models a planet with an atmosphere that is rotating that you're flying on. It has
I'm talking.
Coriolis and everything else
Keep
in it.
going. Are you done?
I answered your
I
question.
said Microsoft Flight Simulator, the most accurate flight simulator that they used, not Kerbal Space Program. I said Microsoft Flight Simulators. Where is the Earth curve in all of them since 2000, like 1999,
Mine's
1997?
on the ball. Mine's on the ball.
There you go.
I didn't understand what you said,
He
but
said it's on. He said his is
it
on
was
a ball.
never
My later is on a globe.
Microsoft. Go ahead, keep ignoring my question, you guys.
I just answered you. You said Microsoft Flight Simulator. It's on a globe.
Yeah, when? When did they implement that?
Probably about
I don't know when they
2012.
wanted it to be more realistic.
So the guys in 1999 and 2000 that were learning to fly with this, are they just were wrong in their learning on how to fly?
Who was
It's
learning to
not
fly
critical
on
to learning how to fly.
Who was learning to fly on Microsoft Flight Simulator in 2000?
I can tell you, I'm sure a lot of pilots that are flying right now were
I
using
practice
Flight
on it.
Simulator in 2000. Guaranteed.
They may have played it, but they didn't learn to fly a plane. If you're talking about an actual flight simulator, a true flight simulator, I seriously doubt in 2000 they was using Microsoft Flight Simulator on PC.
Another one answer.
Actually, today there are certain things in instrument training and stuff that Microsoft Flight Simulator qualifies as flight time.
Yeah, I could see that now.
Well,
But in
there's one
2000,
honest answer.
I wasn't thinking. If you go back and look at it in 2000, it looked janky as fuck back then.
What makes an inertial is when you change your tangential speed with the rotating reference frame. Now you're in the inertial frame.
No, hang
Anything that
on.
does
Tell
that.
me,
The bullet,
how do
when
I?
you drop something, when a plane's flying, any Dude, you guys are really talking about the planes in the inertial frame before there even is an inertial frame. You know how stupid that sounds? Like seriously, man.
It does sound stupid
At least know what the
because they're.
fuck you're talking about before you get into these fucking debates and shit.
That's what I'm trying to ask you for. You could do some of that.
If there's a misunderstanding, just kind of, it doesn't really help to attack the persons. It's just best to kind of attack the information, and the truth will rise to the top, and the things that are false will not rise to the top, and that's it.
Yeah, no, that's dope. Here's the information. There's no inertial reference frame when the plane's just sitting on the tarmac, not moving. Just like a merry-go-round with a ball. If the ball's just sitting on the merry-go-round, not moving, still rotating with the merry-go-round in the same spot, there is no inertial frame yet. There's no Coriolis. Once there is an inertial frame and the non-inertial frame, then you get the Coriolis effect.
Where's the inertial frame?
The inertial frame will be when the plane starts moving. If you're in the plane, you will be in the inertial frame.
No, where? You said when. I'm asking where. Where is it?
Where? It's in the plane. It's with the plane, the movement of the plane.
In the plane?
Yeah, the plane's in the inertial frame, yeah. They're moving. They change their tangential speed with the rotating reference frame. That means you're in the inertial frame now whenever you do that.
How big is that the reference frame of the airplane?
I don't know how big it is. I know when you're in it and when you're not in it, though. And I know when the plane's sitting on the tarmac, it's definitely not in it because there isn't one.
Okay, so there's someone in the ground looking at the plane. Is that person in that frame?
I don't know. Are you conceding that the plane is not in the inertial reference frame when it's sitting on the tarmac now, or are you just going to breeze right by that one? Like
No,
everything else and never come to a
I'm
conclusion?
just trying to understand what reference frame means in your head.
It's an area where you view motion from.
Okay, so all right, what makes that inertial?
What makes it inertial is when you change your tangential speed with the rotating reference frame. Now you're in the inertial frame. Anything that does that. The bullet, when you drop something, when a plane's flying, anything.
Okay, well, you just said that the reference frame is like an area where I can, how do you say, observe motion from? Something like that? How do I know if that area is inertial?
How do you know?
Yeah.
When you've changed your
tells me that
tangential
that's inertial?
speed, when you've changed your tangential speed with the to the reference to the rotating reference frame.
Which one? Well, hang on. Now explain me the first before you bring a second one, right? What reference frame are you talking about? Like when you're talking about an area and you're saying that this area is inertial, I'm just asking you what makes that area inertial. Now you're bringing another reference frame that you haven't described yet.
Yeah, that's what makes it inertial. When you change your tangential speed to the rotating reference frame. Now you're in the inertial reference frame. That's how you get in the inertial reference frame. That's how you get the Coriolis effect. If you don't have anything in the inertial reference frame, there is no Coriolis effect.
So if
wouldn't the inertial frame be stationary?
Left lane, this isn't like a Coriolis 101. I mean, you guys don't know about this. I'm here to teach you about it.
I asked Bacon a question. I thought maybe he would answer.
Oh, okay. Yeah, go ahead, ask it.
Wouldn't a stationary frame be the inertial frame?
A stationary with respect to what?
Observing motion.
No, not necessarily. Yeah, the difference between an inertial frame and a non-inertial frame is that the inertial frame has no pseudo forces. But I was just trying to understand what Jeremy thinks a reference frame is.
I already told you.
Yeah,
I already did that dance.
It still didn't make enough sense. You just
answered a couple
questions
motion from
in a very confusing way.
It's a place you view motion from. Guess who I got that from? Zanuck.
All right. Now, that part is fine.
Straight from Zanuck.
Hang on. That part is fine. I already understood when you said that. I'm trying to understand now the difference between inertial and a non-inertial frame, and your understanding of it. And you're talking about tangential velocities, but hang on.
The non-inertial frame is rotating.
a non-inertial frame is necessarily rotating?
For the rotating reference, dude, we're talking about Coriolis. In order to have the Coriolis effect, bro, we're talking about Coriolis, right? You got a rotating reference frame. Do you understand that?
Yeah.
Okay. Now, in order to get the
Actually, no,
Coriolis
because I don't
effect,
know
you have
what you
this
mean by
rotating
that.
body.
Top 5.
Dude, what? I don't know. You don't know about the Coriolis effect. Get at me when you figure it out, and then we could talk.
I
Like
already
I'm at
figured it
like an
out, but
advanced
we're not
level.
talking about
This is like very frustrating. This is very frustrating. Have to explain like the basics of the Coriolis effect. I don't know why we're doing this.
I know very
from
well about the basics of the Coriolis effect.
so in a rotating reference frame, and then someone outside that rotating frame, and that ball, he sees that ball go in a straight line. That would be the inertial frame because it appears the ball's going straight, right?
Yeah, if an object isn't accelerating, then
I
its
love how
path
you got that all backwards, left lane. The ball is
isn't
actually
accelerating.
going straight that appears to take a curved path.
If an
But
object
the
is not
ball is
accelerating,
actually going straight, you guys.
No, man, it gets so confusing. So in the non-inertial frame
Why
is
do
where
you
you're
guys
going to
confuse this
observe.
issue?
You're going to observe the fictitious force within the non-inertial frame, right?
exactly. That's exactly what tells you you're in a non-inertial frame that you have fictitious forces. If you don't have fictitious forces, then you're not in a non-inertial frame. Then your frame is
So you
inertial.
are in it. So hold
What
on, man.
a
Hold on a second,
fictitious
dude.
force
Rob,
is.
hold on, bro. Please. So you are in reference frames because you just told me you couldn't be in reference frames 5 minutes ago, but just now you described being in reference frames.
Yeah, I mean using.
Very bad form. You want to take a mulligan?
Yeah, I mean using them. That's all I mean. I'm not talking about entering and leaving as you were. That doesn't make any sense.
It does make sense because, like I said, before the plane takes off and it's just sitting on the tarmac, there is no inertial reference frame.
There's no
It
way.
doesn't even exist.
There's no way. There's no way for inertial frames not to exist. You can always describe the motion of. You can always describe motion using a certain frame where there is no pseudo forces. That frame is inertial. You can always do that.
All right, so here it is. So this is from ChatGPT AI, right? So if you throw a ball while standing on a merry-go-round, here's how the reference frame works. Perspective of the ball. The ball itself is always in an inertial reference frame once it leaves your hand. Ignoring tiny air resistance, it travels in a straight line and constant velocity unless a force acts on it. It does not feel the rotation of the merry-go-round once it's no longer in contact. Perspective of the merry-go-round. Your frame is non-inertial because the merry-go-round is rotating. In your view, the ball appears to curve or veer off unexpectedly. This is because you are in the rotating, accelerating frame where you must add fictitious forces like the Coriolis force and centrifugal force to explain the motion.
That's a good
Right.
explanation.
Now answer me something. Let's say you're in the inertial frame and the ball is still rotating with the merry-go-round. So we haven't thrown the ball yet. You're just looking at the merry-go-round and the ball. The ball, according to what you just said, is not in the inertial frame, right? Because it's rotating.
Only when it leaves, it goes into inertial frame when it leaves your hand.
Yeah, if the ball
I
was in
just
the
said-
inertial frame, you would have the Coriolis effect.
Hang
you
on.
don't get the Coriolis effect till the ball leaves your hand.
That was yes or no
obviously.
question to Elbow. Can I get the answer to
I know it sucks when you can't get yes or no answers, right?
Well, at least elaborate.
Yeah,
Like,
but why you want to switch the perspective? But we're talking about when something leaves the rotating frame, it becomes part of the inertial frame, and this is where you have the contention. Once if it's on the non-inertial reference frames, it's in the non-inertial reference frame, meaning it's rotating with the system, with the merry-go-round, or the Earth, according to you.
Hang on. Let me try asking that question again, because I really want to know your answer.
But okay, but the question don't change the topic of how the thing goes. Now try to switch it up because that's kind of like a you're trying to play a word game there.
No. Okay, I'm gonna ask the question again.
Yeah, that's all
If
they
you're-
have left is
let's
word
say you're-
games from here on out for real, dude.
Yeah, thanks. That adds a lot to the conversation. Let's say you're standing next to the merry-go-round and the ball is still in the merry-go-round going around it, right? Can you still see the ball going around the merry-go-round?
If you're standing outside of the merry-go-round, can you see the ball going around the merry-go-round?
Yeah.
I call this mental gymnastics. It's keeping us all fit.
Yeah, so the ball is in the non-inertial reference frame, and you are in the inertial in the reference frame.
Right.
Because you're from the outside perspective.
Can I see the ball? Just say yes to that.
It's a merry-go-round, of course. Yes. Why not?
Okay. Jesus Christ! It wasn't that hard, was it? All
I
right.
don't understand your question. That's why it's confusing because why would I need to answer a rhetorical question? Of course, you can see them.
He's not
It's
through.
not a rhetorical question. I'm trying to make a point. Right, so I'm trying to get there with baby steps. Because if I take a step too long, it happens what just happened, right? So let me try baby steps. You can still see the ball. Can you measure the velocity of the ball by standing on the inertial frame, looking at the ball, going around the merry-go-round? Can you still view the motion of the ball from that reference frame?
This is like a red herring. I don't know where you're going with this.
Yes, you can.
Just answer the damn question, man.
I mean, why? You're going off to the weeds when we're talking about this is an inertial reference range. It has nothing to do with if you could see a ball or measure the distance or measure how fast it's going.
Why can't you just answer his question? Why can't you just answer?
Nonsensical. You're going towards a red herring. What the heck, man? Why are you going on looking at the ball or seeing the speed or measuring the speed of something when we're talking about rotating reference frame and inertial reference frame? What does that have to do with measuring speed or looking at something?
I had no issues answering question about bullets in the middle of a conversation about airplane, right? Even though I don't think it's
I wasn't here for that, so don't blame me about that.
I'm not blaming you. I'm just telling you, like, it doesn't matter if the question seems unrelated. People make points with questions that initially sound unrelated, but you don't want me to make.
Okay, can you get to the point then instead of asking this little odd freaking questions that has nothing to do with inertial or rotating reference frames from a non-inertial reference?
I need the answers to the questions so I can make my point. They're easy. I don't know why you're not answering them. Okay, so I can measure the speed of the ball by standing next to the merry-go-round, right?
You really
Yes,
need
you
the
can.
confirmation. Why don't you just make your point?
Okay, how is that speed not in the inertial frame? Or is it? Is that speed?
If it's on a rotating, it's accelerating. That's how it's not in the inertial reference frame.
Yeah, but I'm measuring the speed of the ball. That's the velocity of the ball is the frame that I'm using, right?
From your inertial reference frame?
Yeah.
Okay. So what?
So the ball is rotating in my reference frame, right?
No, it's in the non-inertial reference frame because you're not with the ball.
But I'm viewing the motion of the ball. And I'm not
from an inertial reference frame.
Exactly, from the inertial reference frame. That's what I just said. So the ball has a certain velocity in my reference frame.
It has an acceleration because it's going around in a circle.
Yes, if it has a velocity, it has an acceleration.
It doesn't have a constant velocity, it has an acceleration.
I didn't say constant velocity. Well, obviously, if it's accelerating, it doesn't have constant. It has a velocity, right? It's moving. It's not stationary.
Okay.
Okay, so you just described the motion of the ball on an inertial frame. The frame where you said the ball is not. So I can still do exactly the same thing whether the ball is in the frame or not. So how would that make
red herring to what the point you've been arguing about
bro.
that.
Jesus. It's word games from here on out, bro. Don't get frustrated, Elbow.
Well, I can nothing changes if the ball leaves the merry-go-round or not. It's still in my frame in both scenarios.
Mental gymnastics. We're staying fit.
Heck are you saying, man? Like what are you What is?
Am I
Oh
wrong?
my God! Are you just? Did you? Okay. Are you conceding to the point that when the ball leaves the inertial, the non-inertial reference frame, goes into inertial reference frame once it leaves the hand?
It was already in the inertial frame because I could already view
No,
it.
it's not. If it's on the rotating frame, that is the non-inertial frame because it's
I agree.
accelerating.
I
Once
agree
you
because the
let
rotation is not inertial.
it goes into the inertial reference frame because it's no longer accelerating. It has a constant velocity in a straight line.
Right, but it already had the
Understand that
velocity in the
part?
inertial
Do
frame,
you
right?
understand that part?
Yes, that's
It's
not
no
what.
longer turning with the rotating frame. Therefore, is now in an inertial frame. Regardless if you could from an inertial reference, another inertial reference frame, you could tell that how the speed or velocity of anything. It has nothing to do with it. Now,
Right,
what
but
you
it already
can
had a position.
no. You were just denying that it went from the not that it never left the inertial reference frame. That's what you said a few minutes ago.
I'm not disagreeing that. Hang on, I'm not disagreeing that it is in the inertial frame. I'm just saying it never leaves it.
No, it does leave if once it's on somebody's hand in the rotating reference frame. In
You
the
can view
non-inertial
the
reference
motion
frame.
of the ball.
It's no longer in the inertial reference frame.
You can view the motion of the ball from both frames at any point in time.
If you are on the outside looking in, yes.
Well, no, you can view the motion of the ball from any point in time, from any frame.
You are saying that the ball never left the non-inertial reference frame. You're telling Jeremy that he was wrong, that he was confused or something. That it never that it was, or he was saying some kind of gibberish when he said that it was not in the that it never left in a frame, the non-inertial reference frame. That it was always. It was in the. You always say. Did he say non-inertial reference frame, Jeremy, or he was always in the inertial reference frame? Which one did he
It's
say?
always in both.
No, it's not.
At any point in time, you can describe the position, velocity, and acceleration of the ball in both frames. It's always in both frames.
Jeez.
Yeah, but then it's just pointless. It's pointless talking about the Coriolis effect if you're just saying everything's in all frames all the time.
It's not.
There's no point in even talking about. Literally,
It's not.
Rumpus told Zanuck this. Hold on,
But
man.
it's not even
Rumpus
right.
told Zanuck
Hang
this.
on.
I know. Rumpus told Zanuck this one day. He's like, if you're when you say everything's in all reference frames all the time, there's no point in talking about it anymore because you can't differentiate now when you have the Coriolis effect or not because something has to go inertial and be in the inertial frame in order to have it.
No, you can. You just have to use inertial or non-inertial frame. When you describe something, you have to pick a frame. You have to be in that frame. That doesn't make sense because they're always in all frames. And it's not pointless because you can change which reference you're using to describe something. There is no necessity for you to be able to enter and leave frames to use them to describe velocity.
The ball will always be in the non-inertial reference frame if it's on a accelerating area. In other words, if it's on the merry-go-round, it will be in the accelerating reference frame, which is the non-inertial reference frame.
Say that again?
Well, you can't keep up with our gymnastics?
I'm just asking him to repeat.
The ball, if it's on the rotating area, the accelerating area, it will be on the non-inertial reference frames. Once it leaves, then it will go into the inertial reference frame. So you can't say it's on both, and then all direction, and inertial references at all times.
Yes, you can, because the ball
No, you
still has
can't.
velocity. Hang on. Well, I was elaborating on my statement, right? You can measure the velocity of the ball before the ball leaves the merry-go-round, even if you're standing next to it. So the ball has a velocity in your frame, it has a position in your frame, it has an acceleration in your frame before it leaves the merry-go-round.
Does it have an acceleration? Hold on.
Yes, your frame does.
When it's on the rotating area, does it have an acceleration?
In your frame, it does.
Yeah, this is now mental gymnastic, bro. Yeah, you're being such a glober. You're being such a
Do
glober.
Newtonian physics apply when it's in the non-inertial? Or you said earlier like something doesn't apply or something. What doesn't apply when it's in the non-inertial reference frame?
Yeah, in non-inertial frames have pseudo forces. Inertial frames do not.
Yes. So is there any pseudo forces when when the ball or the plane or whatever is just sitting on the non-inertial reference frame spinning?
Depends on which frame you use.
I don't know. Whatever. Good luck with this, Elbow. I just did an hour-long word game with Left Lane about the word turn. So good luck.
Rio's using the way pilots use it. So what are you on?
I think Jerry, when that's their point, make you bow out. Just keep you with nonsense statements.
Well, the feeling is mutual.
Because I swear, bro, that's just you straight up nonsense. You're going off on different tangents and not even addressing the actual point.
Which point?
That you're wrong.
On what?
I'd like
Because
to address the pseudo forces, if that's possible.
I couldn't catch that.
I would like to address the pseudo forces.
Sure.
Because a pseudo force isn't really a force at all, is it?
I'll define a force.
No, we don't need to define a force to know that a pseudo force is not really a force at all, right? Without mental gymnastics.
I need to know what you mean by force so I can know if a pseudo force fits it or not.
Really? Really? You need to know what I mean by force.
Yeah. Define it.
So you don't have a definition of force that you could apply to my statement?
Yeah, I have more than one. I have two.
Oh, so you don't believe in the law of identity? So you can have it
I
be
do
two
believe
different
in
things
law
at the same time? So it can
No,
be
that's
two
not what I mean.
different things at the same time? Or how does that work for you?
Yeah, a word having more than one meaning is not a violation of the law of identity. Law of identity is not about words only having one meaning.
All right. So do you really need to know the definition of force to know that a pseudo force is not actually a force at all?
Yeah.
Why do you need a definition of force when I put the word pseudo in front of it?
Because depending on the definition of
Wouldn't
force,
you want to know what the word pseudo means as well?
Yeah.
But you didn't ask about that one, so you must know what pseudo means. You must also know what force means. So when I say pseudo force, you just lose all knowledge?
Well, a cowfish is not a cow or a fish, right?
Yeah, but Rob, it's kind of a wording. I mean, like centrifugal force, like when you spin something and it'll fly off. Like they refer to that as a pseudo force. It is obviously something that's happening. Like if you have water on a tennis ball and you spin it, the water's going to fly out. Well, what's causing that water to fly off? So I mean, they'll call it
of the ball.
Right, but I'm just saying it's the wording of. I mean, I don't really agree with the wording, so I do hear you, but there is an effect that they're applying the wording to. So
It's a visual effect, but
No,
it's
not.
only because it is purely a visual effect of the ball flying in a straight line. Because you are turning underneath, it looks like it's curving. But
It
it's
is
not
curving the frame.
actually curving. That's why you call it a pseudo force.
Let's all relax, please. All right, relax.
I'm so relaxed right now.
Okay.
I'm just doing mental gymnastics. I'm trying to stay fit, Jeremy.
Right. If you define a force as tendency of acceleration.
No, you
then
needed
hang
the
on.
definition of force.
Yeah, I'm trying to give
the
you
last
Don't
few
twist it
hours.
on me.
You know that meme when it's like, "Why are we all screaming?" Like, the last
I
few
know.
hours.
I know. Because they're playing word games with us, Gio, and it's mad disingenuous. That's why. It's mad frustrating.
Oh, Gio just asked you not to attack the person.
I'm not trying to attack
I'm just
anybody.
stating facts. You're playing
No, not
fucking
you.
word games. You, left lane. That's all you guys have left is word games at this
Well, the
point.
feeling is mutual. I'm not gonna call you disingenuous all the time.
Okay. That's fine.
All right. Okay.
Well, it was a little bit disingenuous to ask me for a definition of force when it wasn't necessary, when the word pseudo is put in front of that word. All we were trying to determine is if pseudo is a satisfactory word to put in front of the word force. Because
let me
if
explain
it
to
is
you
an actual
why the-
force, could you describe the actual force that's happening? Because in Geo's tennis ball example, I gave a cause for why the water would fly off it.
Yeah, but see, to me, like the way they use this term, like you could almost call it anything. Like you could call it, doobly doo. You could call it any word. Like it's
let me tell you what you can call it.
Go ahead.
Sorry. Yeah, you can call it two things, right? So as I said, I had two definitions of forces. Like one is just the tendency of acceleration, right? If something has a tendency to accelerate, then there's a force there. This definition includes pseudo forces, because pseudo forces create tendencies of acceleration in non-inertial frames. So yes, force exists. A pseudo force is also a force in this definition of force. Force is a bigger group that includes pseudo forces. Now, if you want to describe an interaction that creates a tendency of acceleration, that excludes pseudo forces. So depending on which one of those definitions you want to pick, then it might include or not include pseudo forces.
Well, by putting the word pseudo in front of the word force, negates it as being a force. Just by using that word pseudo in front of it.
Yeah, if language was used perfectly without any ambiguity,
Well,
never,
I'm trying to pick my words wisely.
That's not how language works then. Like you have things that don't exactly mean what the words are, like a cowfish, right?
That's why I'm trying to agree to terms first. I want to make sure.
That's why I defined force to you. I just gave you two very precise definitions of force.
Pseudo.
Yeah, a pseudo force. Okay, I'll define that too. A pseudo force is a tendency of acceleration that only exists in a non-inertial frame.
All right, I'm gonna investigate that claim when I get home. I can't look at anything right now. I'm driving.
Right. Basically, there's two reasons why tendency of acceleration exists. One reason is an interaction. For example, if you have two magnets, there's an interaction between them, right? That creates a tendency of acceleration. That's a force. That's the electromagnetic force.
Yeah, magnetism I would call a force. Yeah.
All right. Yeah. So if you want to describe like gravity, like Newton, then mass is causing the tendency of acceleration. So again, you have a force, right?
Well, yeah, I don't know if I agree, but I'll let you go with that for now.
I'm just saying that's how Newton describes it. Like I'm just saying that's how Newton describes it. Okay. So now, if you pick a centrifugal force, for example, there is no interaction. That is like if you have water inside of a centrifuge and the water is being pushed against the wall, there is no interaction that is pushing the water against the wall of the centrifuge. The water just wants to go in a straight line, but the wall of the centrifuge keeps getting in the way. So there is no interaction creating that tendency of acceleration. So that's not a true force.
What? Yeah, well, but the spinning of the centrifuge is not causing anything to happen.
It is. It's pushing the water in the tangential direction.
Okay,
not
so
in the
centrifuge
outside
is
direction.
creating a force.
Yeah, not centrifugally. It's perpendicular to that. It only creates a force that is not centrifugal. It creates a tangential force. Like
Okay.
if you check the if actually it's
But
a
that
centripetal
tangential
force.
force is acting
Sorry, it's
on
a
the
centripetal.
water.
Yeah, exactly. It's keeping it from it keeps changing the velocity of the water. That's why the water can
Yeah,
go in
so
circles.
I would say centrifugal forces do exist.
Right, but there is no
But
interaction that causes
I
it.
wouldn't call that. Yeah, the direction is moot to me. It's causing a force because the water is moving because the centrifuge is spinning.
Right. But what's
I don't see
acting
a
on the
pseudo force in there anywhere.
yeah, but the only thing that is acting on the velocity of the water is a centripetal force, not a centrifugal force. The centripetal has an interaction. That's the interaction between the walls of the centrifuge, and the water. That
Have
interaction creates a
visuals for this.
centrifugal force. Sorry, a centripetal force.
Listen, I'm not at home yet, so I'm sorry. I'm slow, man. I'm not the smartest
No,
or
no problem, no
sharpest
problem.
crayon in here, so I would need visuals for this.
That's fine. That's fine.
I'm not home yet, so
No, that's all right.
I
That's
can
fine.
continue
Yeah,
this once I get home.
if you're spinning a rock tied to an end of a string, if you're
That's
spinning
not a
it over
problem.
your head, like you're spinning it over and over and over your head, a rock tied to a string, when you let it go, it's going to just go straight. Whichever way, wherever it's at that moment in time, it's going to go straight. Even though if that rock, while it's spinning, feels to that rock like it has a force pushing outwards away from your hand, when you let it go, it don't fly outwards, it flies straight. That's because the force is wanting it to go straight. It's not a force pushing outward, even though it feels like to the rock that there's a force pushing outwards. There's not really. That's why it's called a
Oh, hang on.
pseudo force.
Let me correct you there, because there is a centrifugal force in your hand, but there isn't in the rock. Like
Well, okay.
hang on, the string that connects your hand and the
The
rock.
string is a very
Hang on, hang
important
on, hang on.
part of that whole. Yeah, go ahead.
Sorry. Yeah, the string is doing the centrifugal force in your hand, and it's doing the centripetal force on the rock. But there's nothing doing a centrifugal force in the rock. So the centrifugal force in the rock is the one that doesn't exist. The one in your hand exists, and it's being done by the string. But the rock doesn't have one. That makes sense?
Yeah.
Yes.
So you cleared it up. That's good. But you get what I'm saying, though. If you let it go, it don't fly outwards. It flies straight. Whichever way it's at
Exactly.
that moment, it goes straight. Even though it, to like I said, to the rock, it feels like there's something pushing
Without
outward.
the
There's
string,
not
though,
really.
you couldn't even do this.
It don't matter. You could put it in a
But
centrifuge, and it's the same
isn't that what
thing.
an orbit is?
And on the orbit, the string would be gravity, right?
So couldn't
That
we consider, like, remember, I ask for a demonstration of an orbit all the time. And, and Coal Miner Man just did one without even thinking. But the problem is there's the string involved.
Yeah, the gravity would play the role of the string.
So, okay, I'll let that go. I'm exercised out for the next couple minutes until I get home. Sorry, guys.
That's all right.
worked up a sweat, brain sweat.
We actually years ago used the rock on a string, but the string got the horse laughed. Oh, they think a string's gravity. Oh, that's why we quit using it.
That's about right.
Yeah, but that stuff's all happening on a stationary Earth with no curvature. So, what they call like centrifugal, if they call it fictitious, somebody wants to call it that, they can, but it doesn't require a globe for any of that to be happening.
Of course, yeah. This is not. Yeah, this is not globe related. This is just physics.
I mean, it is weird that they claim we're on a big ball and it's spinning and we're not flying off of it, which is what would actually happen in real physics. So they do have a kind of pseudo fake force of gravity. Not that all gravity is fake or whatever, but the way they describe it.
Yeah.
And the way they describe it.
Gravity is what's keeping everything on the ball.
Yeah, clinging things to the ball and then like counteracting centrifugal. Like it is all kind of connected in that way.
You can calculate the centrifugal force on the globe, and it's really, really small. I've seen several people do it in real time. It's like crazy small.
That's not that crazy small. Like
I mean, it's a lot smaller than gravity.
It's 0.03 meters per second, and it's like 0.3% of gravity itself.
Yeah, that's what I'm saying.
Which is measurable.
Yeah. I measured it with a pocket scale.
Yeah. Well, this is just like all the other little globe tricks that they use. Like, just because weight changes with latitude, let's say it does, that doesn't mean that that's centrifugal force and the little bit of counteracting compared to what gravity clinging everything to a ball. That's still a pseudo physics concept in terms of everything sticking to the ball. And then just because there's a little bit of weight change doesn't mean you're measuring centrifugal force.
Of course, but that's not the argument. The argument is not that because weight changes, then Earth's spinning. The argument is, okay, if Earth was spinning, then we could measure an exact amount of weight change if we went from this location to that location. So let's check if that holds. And it does.
Okay, but you could do that with anything. You could say, well, if Superman, flew into my house at 80 miles an hour, it would have broken the window, and the window's broken. Therefore, it was Superman. You know what I mean? It doesn't mean it's true. Just because you can correlate some concept with it. You can do that with all kinds of stuff.
No, I'm not talking about correlating a concept. I'm talking about making predictions. Like I can tell, you tell me where you are, I tell you what I am. If we switch locations, we can use a pocket scale and then predict if we were in a spinning globe, what should be the difference, and then you can measure. And we might miss or we might get it right.
Does that prove you're on a spinning globe?
That's
like
good
I said, I could also predict that if I wake up with a window broken tomorrow, that Superman was the one who flew into it, but actually it was neighbors throwing rocks or some other reason.
But that's not a prediction.
Why not? If I predicted that tomorrow my window's going to be broken, and it ended up being kids throwing rocks, but I have a whole predictive thing that it was Superman, that he was going to be coming around at that time because he's delivering presents to kids or whatever, and he's gonna fall out of the sky and break my window.
Yeah, but you could predict that Superman would break a window in any other day. So there is no tight prediction to the existence of Superman. There is a tight prediction to the rotation of the globe, which is how much the weight changes. If it doesn't match, we can't just change something, say that the Earth is whatever else. That just doesn't work.
That's fine. If you want to yeah, it's fine. If you want to nitpick the way I use the analogy, it's fine because it wasn't a perfect analogy. But you could use a different one and say that you have a whole theory of ether drift, and you predict that the pendulum will process precisely how the ether will drift, or that ether is causing the weight change. You could come up with a whole theory on that, and then you could say, hey, look, the pendulum processes, the weight changes, therefore ether true. And that still wouldn't be valid just going off that alone. I'm not saying there's not ether.
I think it would. I think it would be valid if you can derive your predictions from the hypotheses you're bringing. Like if you're bringing this ether idea and you can derive those sorts of predictions from it, actually from it, not just pick the predictions that already exist and attribute to ether. That's not the same thing as deriving them. If you can derive them from your idea of ether, then I think that would be valid evidence for the ether.
But all they did was match the concept to the observations. It's like reverse engineering. So you're just saying if anyone came
Not
up
what
with
I did.
if anyone came up with any theory of ether, which you absolutely could do. Again, I'm not saying this proves ether, though. I'm kind of just using it as a analogy to point out the hypocrisy on the begging the question, affirming the consequent logical fallacy process that this is, where it's not actually isolating what it is. It's attaching some previous concept. Just because the effect happens does not mean it's caused by the concept. You have to actually validate that it is the cause, not just something that happens to match with it.
Yeah, but the way we validate or whether this is the cause or not is try to think of something to measure that would be very hard for us to measure that if that wasn't the cause. That's how we validate these things. And I think the weight changing with the latitude, that's one of those ways. Like, I don't see any reason why weight would change. And for weight to change just as much as a rotating sphere was predict, that's a hard thing to happen if Earth isn't a rotating sphere. So I think that's a valid way of testing that.
So because you can't think of anything else, and because this one seems like a good possible explanation that fits it to some extent the way the theory claims, you think that's strong? Just
No,
because
I'm doing the opposite direction.
Because you can't think of anything else. Well, that's what you said. You said I can't think of anything else that would be. So I mean, that's the extent of how far your mind takes it.
No, like I'm not measuring something and then try to fit something into it. I'm deriving what I expect to measure before I measure. That's at least how I did it. Right? I already knew how much I would expect for the pocket scale to measure differently in south of Brazil and north of Brazil.
Yeah, because you were given
and then
the
I
globe
just went
model.
there and measured.
So the people who did it originally reverse engineered it, is what I was saying. Originally, like for example, let's say
but there's no wiggle room.
Well, let's say the pendulum does precess due to ether drift for a moment. Let's just say that was the truth and we're not on a spinning ball. Let's say that ether drift is like a toroidal spherical thing. Therefore, this toroidal spherical ether is spherical, and let's just say that's causing ether drift. I'm not saying that's the case. I'm just saying let's just say hypothetically that's the case. Then if some deceivers of the world wanted to convince everyone they're on a big ball and they designed the ball model and it happens to fit that because there's overlap in geometry, there's overlap in certain things in reality. If they were to do that and then concocted this whole concept and then handed it off to you or whoever, and then now somebody is saying, hey, look, it matches that whole string would be a completely wrong thing based on a wrong model from an effect that's real, but it's wrongly applied. And so the way you're going about it, I mean, are you asserting this as proof of it, or are you just saying it's just like an interesting tidbit? It's just like a little interesting thing that happens.
I think it's good evidence. I don't think it's definite proof, but I think it's strong evidence.
Well, isn't that based on the idea of gravity being 9.8 meters squared standard across the surface of the Earth?
No.
Because isn't that what you're doing? Like you're basically standardizing the gravitational formula and then saying, well, the variability that happens or occurs around the because of the rotation creates an outward force, which pushes slightly back against the gravity.
No.
Isn't that the whole claim of the reduced weight?
It's not my claim.
Of the rotation of the orbit of the the rotation of the Earth?
No, that's not my claim.
Well, I must have missed the plot then. Well, I don't know what your claim is then. Sounds like I didn't connect the dots properly, so I'll let someone else go.
Yeah, my claim is that Earth is a rotating sphere of a certain size, and that predicts the difference in weight from one latitude to the other one. So I worked out what the difference should be. What?
That's basically what I was implying, dude.
No, you talked about assuming that the acceleration on Earth would be 9.8 meters per second square over the whole surface. That's not at all part of my assumption.
How do you know that there's a reduced weight?
Because I measured it.
Because you standardize the interpretation of what's causing the downward force. All I'm trying to get to effectively, man, is like you're just basically implying that the 9.8 meters squared is standardized across the surface of the Earth. And then when we go scour out across the surface of the Earth, we find variability. And then your excuse for that variability is because because you're on a ball spinning and it's got a, what's that terminology called? What's that outward force?
Centrifugal.
Centrifugal or centrifugal? I can't remember the difference.
Centrifugal.
Are you implying?
There's centrifugal, which is also often pronounced centrifugal, but centrifugal and centripetal. Pedal is inwards, fugal is outwards.
It's the one.
Okay, yeah.
It's the F1.
Centrifugal. So you're implying that there's a centrifugal force across the surface of the Earth?
Yeah, the rotating of Earth would create a centrifugal force. Yeah.
Which slightly creates the variability of what we observe as far as the standardization of the 9.8 meters square, like essentially weight, or is it weight or mass? Weight.
Yeah, I mean, Bacon. Even if you didn't like how he worded it, or you could have like tweaked the wording, but I mean, it's not like he was way off because you were like, no, that's not it at all.
Yeah, it felt to me like he was arguing that my claim would be that Earth would have 9.8 meters per second square over all of its surface. That's just not at all what I'm claiming. Unless he's talking about like if Earth wasn't spinning, then yeah, we should expect essentially the same acceleration everywhere. If that's what he's trying to say.
All I'd be implying is at that point is that like, okay, why does the sky rotate? Oh, because the Earth is turning, or because the sky is rotating. And then whatever that force is that we call gravity is effectively maybe uneven across that surface. And then we go out and we analyze it and we find that the unevenness has some sort of correlation with the drift of the ether in the sky. So all of a sudden there, like, I mean, I think I've connected all of your variables where you said, what was your terminology? We could come up with alternative attributions to the cause of this, and you say that like the ball spinning makes perfect sense. Great, but only if you justify and you basically imply that the gravitational formula is standardized, and where it deviates, it must be because you're closer to the equator and it's caused by this centrifugal force. Now, I might be able to come along and say, well, due to the ether drift and just looking at the way that the vortexes in the sky operate, that in these centralized zones, we would expect to find a slight reduction in that force of gravity. So I end up with the same results as you, but you're attributing it. No, I'm not strawmanning, I don't think. I'm just trying to suggest that I can do the same thing and arrive at the same results, just as you said before. We can find it's just like the causal affect of the observation, like that deviation from the 9.8 meters squared. We can just come up with alternative hypotheses based on that.
Yeah, you can always come up with any hypothesis to justify any measurement. That's not what I'm doing. And I didn't say if there is any variation on weight, then there has to be Earth's rotation. That was not at all my argument. That's where I'm saying you strawman me, because that wasn't my argument. My argument
is a centrifugal force. Oh, sorry, go ahead.
My argument is that if we are on a spinning globe, that's the only assumption here, right? We can then estimate how much change would weight based on latitude, and then you can measure that. If you think there is another elaborate model of ether or whatever that ends up driving the same prediction of the measurements we have, then sure, then I think you have a good model, right?
So we attribute the sky to the drift of the ether, and we also acknowledge that the ether, because of this drift and its concentration in certain locations, that it results in a reduced, ever so slightly reduced weight around the equator at that latitudinal position, correlative to its ether drift.
Yeah, that's just a verbal. Like you're just claiming that would cause a slight difference. You're not telling me how much. You're not telling me how to derive how much.
It's latitudinally based. We find it at the latitudes, and that correlates with what we see in the sky.
If you can derive from your model of ether, how I would calculate the predictions, how I would get to the numbers that I measure, then I would say you have a valid model. And that's fine. I'm not even opposed to that.
You've got some sort of pseudo evidence to show movement, but I don't think that the evidence to show movement itself is actually very valid. We're both referring to the sky at that point, and then we've just plotted a latitudinal value across the surface of it.
Yeah, Bacon, because when you're saying that you're on a spinning globe, but if there weren't gravity clinging things to the middle, then everything would just completely fly off. You'd be measuring a lot less weight than a little bit less. You'd be measuring no weight. The thing would be flying out. So when he's saying the 9.8, I mean, how do you word that? Because you're not just on a spinning globe. You're on a spinning globe plus the theory of gravity, everything's clinging to the middle, mass attracting mass, this whole concept of it's not that things don't fall, we know they do and stuff, but it's that it's clinging to the center of a ball versus just falling down. So, I mean,
oh, it's falling towards Earth. We all agree with that, right?
Yeah, I mean, a rock will fall towards, if you want to call it that, a rock will fall down towards, if it's in air and there's no other factors like extreme winds or whatever else, or magnetic. I mean, if it's just a rock being dropped, it will fall down to other Earth. Yeah, it'll hit some stones.
Yeah. So, and the direction of fall is always perpendicular to level, right? So if I have a level line and I drop something, the direction of drop is going to be 90 degrees from the level, any level surface, right?
Yeah, we agree with that. Cool.
Is level curving
so
or level planar. The point is, though, it's just
hang on.
For the weight change thing to be the case, you have to imply that gravity's clinging things to the center of the ball, like he's saying.
No, that's an implication. If Earth is a ball and things fall towards the surface, like 90 degrees from a level surface, then that would imply necessarily that things fall towards the center of the Earth. That's not something I have to add. That's an implication of Earth being a sphere.
Is that not the force of gravity?
You can put any label you want, but that's not something I'm adding because I want to. That's something I can't not add if Earth is a ball.
What are you talking, dude? We don't even need to add the gravity problem into it. I'm just sort of referring to it as like we both agree upon the downward force. The issue is that we both agree with the value of the so-called gravity, right? Like there's a downward vector. All I'm saying in my concept is that around the equator, it's slightly weaker. And then what you're saying is
Bacon's just saying it's baked in. No pun intended. He baconed it in. It's just baked in. That
I'm saying it's not I'm saying it's just an implication. It's not
I don't even know if you're having a conversation with me, bro.
Well, you're calling it implication. I'm calling you. It's kind of you're assuming it's baked in, but I don't see why you couldn't have said to him originally, like, "Yep," because that's part of. He's saying if you had like the 9.8, as it were, and then you have this slight difference that's in counteraction to the 9.8. Because otherwise, if you didn't have that, things would. I mean, we know what things do. Things fly off balls. So, and when they're spun.
Yeah, but the thing is, we know things accelerate towards the Earth. And if Earth was a globe, that would imply they are accelerating towards the center. Because that's what all normal vectors on the sphere intersect. So that's a must. Okay. That's an implication of Earth being a ball. Now,
so then somewhere on the Earth you're reading 9.6, right?
I don't think so.
Was it 9? No, it wasn't 0.6. It was sorry, because it's 9.8, so it'd be 9.77, I believe. So that's slightly reduced.
I was going to say, if the Earth is a spinning, why aren't we flying off?
Well,
because
I'm spinning around my chair right now, and I'm not flying off because I'm not spinning fast enough, right?
You got friction. There would be theoretically no friction if you turned off gravity. There would be no friction.
Are we turning off gravity? Why would we do that?
Well, it depends. Can you independently manipulate the gravity to make a claim that it is the thing that is pinning us to the ground?
I'm not claiming it's anything. It's just something we observe. Things fall. If you drop something, it accelerates downward at 9.8 meters per second squared. That's just a fact. It's not a claim. Yeah,
but the claim, at the point of which you say gravity, you're either going matter attracting matter, which then suppose like creates the ball for you in your mind.
No, I'm not getting to that. I don't. What?
What you said, everything accelerates towards the ground. You talked about creating a level, and now I want to know at what point is it curving? What causes the curvation? You're just talking about top and bottom down, because your up, it's different to my up, right? In your globe world, I don't know where in the world you are, but I'm in Australia, so I'm pointing down, right? Where's that coming from?
I'm in the
deviation of the perpendicular.
He's basically
a flat earther at this point.
He's across the pond, but in the same hemisphere.
South America? Yeah. I figure Deep Thought sounds a lot like bacon, actually.
Yeah, south of Brazil, yeah.
Cool.
I think, is Deep Thought from Argentina or?
No, he's from
Yeah, I think
Uruguay.
so.
Uruguay. Okay. Yeah.
Uruguay.
Okay.
Yeah.
Oh, is he?
Yeah.
He's got a similar
Yeah, that
accent.
sounds
My
right.
bad.
But Bacon, I mean, the thing is, dude. So okay, I mean, I hear like kind of where you're coming from. Like it's like all baked into it. But the thing about this though, like to say okay, Earth is a ball, to say like all the Earth is in a ball. I mean, you would really have to say like because you're saying if Earth is a ball, like in this weight change thing, you would almost have to say if it's a ball and if it's in a vacuum and that everything's clinging to the middle of it. Because I would say this. Imagine like from a stationary planar flat earth type perspective, imagine if you're in the same medium, up is up, down is down, things go up, things go down, right? If you were to take all the earth and ball it up, things would still fall off of it because it's in the same medium. You know what I mean? Like everything falls down. It's not necessarily that everything falls to earth. Everything just falls down. And there's an actual vector of down. It's not necessarily to earth. There might happen to be earth in the way. There might happen to be water in the way. You drop a rock, falls into the water. It might fall into your head if your head's in the way. So it's just that the rock goes down. The idea that it's clinging to earth is a whole kind of added like theory, conception, idea that mass attracting mass. And I think that's what, in a way, like what I thought Ritsky, well, at least in my interpretation of it, was like alluding to. Because, you know, like I said, if up is up and down is down, and you took all the earth in the world and you got a bunch of teams together and you globbed it all together, you put it into a ball, things would still fall off of it because down is down. In fact, the whole
That has an
ball.
assumption.
So
I mean, there's an assumption there.
So your assumption, what I'm saying though, is that what we actually experience is thing falling down in a medium. just to say Earth is a ball, therefore all these other things have to go with it, like things are coming to the center of a ball. That would only be the case if you added the idea of mass attracting mass, a vacuum surrounding it. Because if we're just in the same medium,
I don't think you need that.
everything falls down, including if you balled up all the Earth, it would also just fall down. The water would all fall off it. Everything would fall down. See what I mean?
Yeah, saying yes, that also has an assumption. Like that's only true under the assumption that vertical is universal, that all vertical lines are parallel to one another. And of course,
All right.
that wouldn't be the case if Earth was a sphere, but that would be the case
that's
on a
what's
planet.
in content. Okay, but that's what's in contention. I'm just saying, like, I just don't think it's really wild for him to have. I don't know. It just seems like you were like kind of resisting what he was saying, but I mean, whatever. We unpacked it. It's fine. I mean, you were just implying that all those go along with it. I just don't think it's as simple to say as if Earth were a ball. Therefore, this latitude change, because there's just these other factors that have to also be assumed. Because you were saying the only assumption I'm making is if Earth was a ball. Well, anytime there's an assumption, there's a potential problem, you know, in terms of getting to the truth. But it's not really the only assumption, because if you define Earth as rocks and stones, like Earth, the way that, you know, there's a couple different. That's the other thing. The definition of Earth has different meanings too. Like if you look at the etymology, one of the definitions is like the abode of man. Now, if it's the abode of man, then yeah, that would be the entire realm, you know, that you'd be implying. But there's another definition of Earth, which is like the actual, you know, rocks and stones and like the actual minerals. And
Let's say everything under the sky. If that works.
Everything under the sky. So what?
Like me, the buildings, the birds.
No, it's
Just
all
not
good.
the stars,
Maybe
the sun.
I hear you. The like the atmosphere and the ground and the water and everything. It doesn't matter.
Just
My only
everything under
point
this,
is it's all good.
I'm just
Yeah,
trying Sorry, go ahead.
Everything we experience. Yeah, but the thing is, the globe kind of needs outer space, though, or maybe it doesn't. You could have the globe with just an atmosphere, but then if it's not geocentric, you have it spinning. I don't know. All I'm saying originally is that originally with the weight change thing is if Earth were a ball, and it just seems like we unpacked a little bit, but that's not just, you know, if the rocks were all balled up. It's actually like there's more assumptions. There's mass attracting mass. Things fall down, and that's what Ritsky was saying originally. The 9.8 that's generally, you know, more or less equal, you know, within range around this ball. I mean, they claim there's anomalies and stuff, and then the weight change is changing in relation to that. So I'm just saying it implies more. It implies that Earth is defined as the whole realm, like you said, like everything under the sky. It needs that. It also needs the mass attracting mass theory. It needs the idea that rocks will attract to other rocks when there's a lot of other rocks for it to attract to, like a huge globe Earth. And that it implies like, I mean, it has to be spinning in something, right? So then you need a medium to spin in, and that's fine. Like, I mean, you could say your thing, and it's not a big deal that but I'm just saying, like, seems like you were going against what he was saying, but the other things that he was alluding to are all, I would say, additional assumptions in the original one of if Earth were a ball, but perhaps you're using it more in the colloquial sense of the modern era, like if Earth were, the sphere they tell us it is, which I guess includes all those things.
No, I think you don't need, like, if you want to draw the prediction of weight changes, you don't need to include almost none of it. Like, it could be a how do you call it, a geocentric universe. So Earth is right in the middle, as long as it's spinning in a day. Also, atmosphere could just extend forever. There doesn't need to be any vacuum or anything like that. Nothing, like, none of that would change the prediction. That's what I'm trying to say.
Okay,
like the prediction of. Yeah, go ahead.
Can we reverse engineer this? Could you then, with this observation that you're making about the Earth, run across the surface of it, taking different weights and measurements, and then basically produce the ball model?
What part of the blow model? Like the size?
Well, so, like you're saying that the latitudes correlate with a drop in weight. That's the observation across the surface, right?
Yeah, not just it correlates to the weight, but also how much it correlates, matches the spinning globe.
The spinning globe, and particularly the latitude. Right?
Yeah. That's
Cool.
their position.
So I mean, you could basically, if you plotted if you ran across the surface of like an unknown object, or an unknown shape. You could basically derive your observation of the different weight change, and you could come up with a hypothesis that you're on a spinning ball. Is that right?
Depends on what the changes are. Not every weight change would be compatible with Earth being a spinning ball.
Because of other anomalies? You're saying?
No, like for example, if the weight is proportional, like if the the loss in weight is proportional to the sign of the latitude, then that matches a ball. If it follows a different function, that doesn't match a ball. Like if it's anything other than that, it wouldn't match a ball.
I'm asking you, right? Imagine it like we're just dealing with reality. We don't know if it's a ball or not, right? If you can run across the surface of that shape, and using your observation of weight changes across the surface of it, and you map it, you plot it out, right? All across the surface of it. I'd imagine it then end up looking something like two toroidal vortexes. If you were just like to put it on a piece of paper, on a piece of graph, it'd actually end up kind of looking like the dual pole, but then you would need to wrap it around. And then maybe you could sort of at that point derive, oh, actually, maybe if I sort of twist this graph that I've mapped it out on into a ball, then I think you could reverse engineer the ball. That's what I'm trying to suggest right now.
I'm not talking. Yeah, it's not really.
You believe that you live on a
analogy.
ball, you think that this is the proof. The proof
No, I
then
don't
should
think
be
this
you
is
should
the
be able to
proof.
take the.
I said otherwise already.
He said
It's
strong evidence. To be fair, he did say strong evidence.
Okay, strong evidence, right? So you think. So you could basically imply then that you can use it as a reverse engineering to get back to the ball.
No, I think if you only, for example, if you only give me list of weight changes, I can't derive the shape of the Earth with just a list of weight changes, right? If you give me
You
a list of
cannot
weight
derive.
changes,
Could you make a hypothesis? Do you think at that point, or not possible?
it sounds like that's too few information to make a hypothesis on the shape of the Earth. Just a list of weight changes.
But you're saying, if you're saying, right, that the reason why you believe it's a ball is because the piece of evidence is that the weight changes across the surface of it and they correlate with a ball, and you're saying that's good evidence, but you can't backwards derive it, I don't think that you're really necessarily saying that that's good evidence, because you should be able to reverse engineer it back into your ball.
No. No. Measuring the weight is just something that I wouldn't be able to do without a model of Earth. And what happens is if I use the globe model of Earth to predict that, it matches the measurement, right? So I think that's good evidence for it. I don't think if I only had the measurements, I would be able to derive the globe. But I would be able to see that it matches a globe, and I wouldn't find a way to match that to a flat Earth, for example. But that's not the only thing I have.
Model to compare it to.
Say that again?
No. Yeah. What? No. What? No, I think what Rick's saying, yeah, if it's evidence for something, then that means that. Well, I guess it could be like corroborative evidence, but I mean the idea is that like you're trying to, if you have evidence of something, shouldn't it lead you to the truth of that thing if it's the truth of it? Or are you just saying it's evidence that's like partial? It's partial.
But here, yeah, it is partial. But like, for example, let's say we have a crime scene, right? So you start collecting evidence. So you collect a bunch of things, DNA here, position, and that the person died here, the trace of a bullet there. So once you connect all those things, let's say it clearly points to a specific murder, right? And then you say, okay, well, if it was murdered like this, then we should find also this and that. And then you go look and you find that exactly thing you expected to find, given the scenario of a murder that you just came up with that matches all the evidence. Now, if you just pick those two last things alone, that doesn't necessarily have to give you the full murder. That doesn't mean it's strong evidence for it.
Well, the fact that it doesn't, though, means that you could have a problem here where you're not actually on the true thing because you only have a partial thing of an assumptive that even kind of makes it like I was thinking in that analogy, like let's say you found DNA right on the on the gun, but you actually don't know if maybe the killer took took some blood from someone, and then wiped it on the gun, and the guy wasn't even there at all. You know what I mean?
Right.
So yeah, but
Yeah. Like I'm not opposed to a different hypothesis. Like I'm saying there are probably alternative hypotheses that could explain the same things. That's fine, right? Like I don't oppose that. If you think, as I said before, if you think there's an ether theory that predicts the same change in weight that is derived from this idea, right? Then I'm gonna say that's actually a model, maybe as good as the globe. I'm not gonna oppose that.
All I'd suggest it would be is just I understand why you're not kind of getting it. There's a variability of the if gravity is to be electrogravitic, which basically on a flat Earth would have to be the case, I think. I can't think of too many other phenomenon. Just very hard to detect, obviously. So on a flat, like you don't have this gravity concept that you can wrap things around in. So then if it's flat, it must be electrogravitic. And then at that point, I would just suggest that the affect of the electrogravitics across the surface is not standardized. It is, it undulates slightly.
Yeah,
and then when you map it out over that graph. So if you're like that graph of paper that I was saying before, like I could imagine on your map that when you you create all the dots across the surface of it, you'd end up with a dual pole model. And then you'd start coming up with concepts of 3D geometry. And that's how you would derive your globe. Looking at that exact same graph, just draw two circles that are concentrated in what we call the north and south, and then just say, well, the field is concentrated at these two locations, and through the middle of it, there is a slight reduction in its affect, thereby creating a reduction in weight through the equator. It may be that
I have no idea how to verify what you just said.
There's too many. Well, I'm just trying to what part aren't you getting? The fact that I'm putting it on a piece of paper, and then if I put all these dot points and concentrate them at the north and the south, indicating that it's a greater weight in the north and the south. Do you know what the dual pole looks like?
Yeah, like if we maybe I'm thinking of it like let's say in more ancient times, you and I have a boat and we have a scale and that's it. And we're boating around the world. We have a flat piece of paper on our table in our boat, and every time we get to a spot, we measure the distance or whatever, we get there, we say, okay, now we're here, latitude, longitude, if you want to use the sky, whatever you want to do. And you put on your flat sheet of paper, right here, the weight is this. And then you go to another place, the weight is that, weight is that. What he's saying is that like you would end up with like essentially with that dual pole, because you would end up with like two hemispheres, and then the weight change would be changing in latitude from the South Pole to the North Pole. You would then have to like wrap it around a globe or put it on a globe in order for it to then be interpreted as a globe. Because all you would have is just, you wouldn't have any reason to assume you're going over any curvature. You're just traveling upon the ground and plotting the points on a flat sheet of paper, essentially. Is that kind of sort of steelmanning what you're saying, Rixie? Is that
yeah, that's it. It's just another way to say it. Yeah. I was going to start going step by step through because obviously he's not understanding. I am trying to jam it through rather quickly with the expectation that he understands. So we can go through it step by step if everyone's like kind of happy and patient to do so.
Yeah, if you started recording your positions on Earth and correlating it to weight, and you notice the longitude doesn't matter much, but the latitude does, and you also record how much the latitude impacts on the weight, I have no idea how you derive a dual pole from that. Of course, if you plot those values on something like an A map, then of course, because the weight is matching the latitude, then that's going to form circles. Right,
it's dual pole because the weight change is different. It's from the South Pole to the equator, and then from the equator to the North Pole, it's symmetrical. You have to have a dual pole, and AE won't work for that.
Well, not if you assume that the South Pole is a pole, right?
Well,
it doesn't have to be a pole.
As you get closer
I don't see
to
why
that pole,
that wouldn't match. Hang on. I don't see why they couldn't match the AE map centered on the North Pole. Like, why is there an issue with?
So now you're telling us the weight change with latitude works with an AE map? Well, we come full
like
circle.
you can exactly. I'm saying you can match it to any map, right? What I'm telling you is that it's hard to come up with a way to predict that, but it's easy if you just assume the Earth is a sphere.
No, because you can look up in the sky, and this is effectively what the globe does as well, is you can attribute the phenomenon and geometry of the sky with that which is going here on Earth.
Okay.
Maybe I can confusing. I'm jumping into the sky, and I'm just trying. I sent you a little message there in the dual poll, implying that you were basically just trying to lay this globe out on a flat map.
I'm not.
And
Yeah.
all I have to do
I
is
don't think you
attribute
can
this
derive a
movement,
globe.
this field.
Sorry.
It's a field. It's just a gravity field, dude. It's an electromagnetic field, right? And the affect is distributed across the surface such that it creates this pattern. And we notice the
Yeah, that's
pattern
a nice
also
claim.
is in the sky, right? Well, it's a nice claim to say that, well, your matter is attracting matter and therefore collecting into a ball, and that's why you observe your universe.
That wasn't my claim.
But no, because you're not even, dude, you're saying it's a ball, and then you've got no reason to call it a ball, except for the fact of this latitudinal, weight change.
No, I'm saying if you start with this, if you just go with the assumption of Earth is a ball, that implies that you're gonna have to measure lighter weights near the equator, and it also tells you how much. That's it. If you can do that with any other model, other than a spinning globe, then that's also good for that model. But I don't think you're bringing that.
Well, I thought you were inviting us to kind of sort of show you how it might alternatively work through another field. And now you sort of I guess you're kind of agreeing with it in principle.
No, if you
So
bring
it's not mutually exclusive now? Is that
that's what I was going to say.
I don't think
the exclusivity.
I don't think,
Go ahead.
Sorry, I don't think there's any piece of evidence that I would bring for the globe that alone is exclusive to globe. There's also, as you can see, you can always think of an elaborate crime scene that might match the same evidence. I'm fine with that.
Yeah, but wouldn't there have to be some evidence that could be smoking gun at some point? But that's why they have that phrase, the smoking gun kind of thing, or the clincher or whatever. And it's any good detective has to kind of do this, and we're all detectives on what the Earth is, basically. Anyone in this discussion, even though people might claim how confident they are in their position, they're still a detective, and they're figuring it out, thinking about it, whatever, no matter how strong they may think they're on a side, which is what a detective does too. If you have 3 detectives and they're all analyzing a scene, one guy might say, I think it was this. The other guy says, I think it was that. But the thing about exclusive evidence, though, if you have exclusive evidence, that is incredibly strong. So if you have exclusive evidence, and whereas if it's not exclusive, then that means that it could be caused by something else. And then does that really make it very strong at that point if it's not exclusive?
It's strong if
it could just 50-50 be something else, then can you really call it strong evidence? At that point, it'd just be sort of possible evidence at best.
I'm saying it's strong when it's easy to come up with a prediction that works under this idea than to any other idea. And that makes it very strong for this idea to be the right one. If you I didn't do any hard math. I just did high school physics math when I came up with the prediction for the weight change. And basically the only assumption I need is the Earth is a ball. Everything else is just measurable, right? You can measure the downward acceleration. I can measure my latitude. Those things are measurable. The only assumption is just the Earth is a sphere. And then that gives me a prediction.
Force. You're assuming
no, that's an
centrifugal
implication.
force, though.
No, that's an implication of a spinning globe.
Because that resolves your constant. Because you're claiming a constant across the surface, and I'm saying the gravitational field is not constant across the surface.
Okay, that's a nice hypothesis, right? If you want to go with a stationary Earth that has a varying force of gravity over the surface, that's fine, right? What I'm telling you is that just with the assumption of it spinning, that gives me the prediction that matched my measurement. If you just say it varies across the surface, then that can match any measurement. Then there's no prediction you can draw from that. The fact that mine gives a specific prediction and my measure matched that specific prediction, I think that's strong evidence.
No, I can just basically draw those fields, so those latitudinal values across the surface, and then say, well, at its highest point, it's 9.8 meters second squared. At its lowest point, it's what is that? 9.77. So 7. I'm getting caught up here. 9.76 or 7. And
How do
I
you
could
go to
just
that
basically
value?
plot that out on a graph, right? I can plot that
How do
all
you
out
go
on
to
a
that
graph and
value?
say, because I went there and I measured it.
Okay, but I didn't measure my values first. I measured them after I have the prediction. You're trying to get the prediction using a model that you're starting with the prediction to
Okay,
do the
so
model.
I drew
And
out
obviously
those.
that's going to
Okay,
match.
well, maybe what would it? Okay, I can draw out those lines in a different manner. I can use a compass, right, and take compass values and measurements all across the surface of it, and plot that on a piece of paper, and then say, well, isn't it funny through this center middle part that there seems to be a reduction in weight, or I can actually predict that there should be a reduction in weight at that point.
Well, if you already measured
Because
the
there's two
weights and
electrical
you're
fields.
plotting, well, no, if you're doing that before the measurement, then you tell me how you're getting to those values. Okay, let me give you the specifics, right? So I measured like a couple objects that added up to 497 grams. And when I measured in the North Brazil, it was 490, I think it was 92. Yeah, 92. So there was a half a gram, sorry, was it? It was half a gram lighter, right? So it was nearly 500 grams in South Brazil. When I got to North Brazil, there was 5 grams lighter, and it was nearly half a kilogram. So you show me how you can get from half a kilogram in the South of Brazil to a half a gram less than that near the equator on North Brazil. And then you have something. If you're just saying I'm going to draw lines and this should be more, that should be less, it doesn't tell me much. I can't draw predictions from you just saying that.
Are you just drawing lines on a ball?
I'm not.
No. So what are you doing then? How are you acquiring that
I was
latitudinal value
calculating.
in order to create
Yeah,
the prediction?
yeah, I was calculating what would be the difference in the weight based on the rotation of the Earth, its size, and the latitudes that I started and the latitude that I ended.
How are
I
you
wasn't
getting
just
those
drawing
latitudinal
lines.
values, dude?
Oh, I can measure my latitude. I can measure in all sorts of ways.
How are you measuring your latitude?
Oh, I can get it from GPS. I can measure it with sextant.
Oh shit, rightio. So the thing that assumes a ball, you can get it
I
off the
actually did
GPS.
both.
Come on, man.
No, I just told you I can also use the sextant. I can use the theodolite to get my latitude. I already use the sextant to get it.
What I don't get that you don't seem to get, or why I don't get why you don't get it, is that I can just put those fields onto a flat piece of paper, right? Attribute certain values to them. You acquire those, what is it, through either like a compass, or you can derive it from what's going on in the sky. And then you attribute your latitudinal value because you want to be able to basically be able to go anywhere on that map and say, I want to go to this latitude and expect to take this weight and transfer into another weight. And your model
Hang
works
on.
just like your idea of a ball works just the same as an electrical field across over a flat surface on the graph.
My latitude was measured. I can measure my latitude. I already did that. That's not something a globe model can control. It's something I can measure myself. It's not defined by the model. It's not something that can be wiggled so my measurement matches my prediction. It's just something that can be measured and was measured. Do you understand that?
I'm pretty much at an impasse here. I don't appreciate or necessarily understand where you're coming from as far as how your ball is able to do predictions. But if I take your ball and put it on a flat piece of paper and then start basically pointing anywhere on that graph, and then you can take it to the true location, you can go to that location on the graph and then notice the weight change. It's basically a prediction.
Yeah, you have to be
I'm
able
just
to
messing around with
derive
the
the
electrical
prediction.
fields. and you've got a gravitational field minus your centrifugal force.
How does messing with an electrical field changes the weight of things regardless on what they're made of?
Proximity, distance.
Okay, show me in real life how you can do that. Change the magnetic field and change the weight of something regardless on what it's made of using electromagnetic fields.
It's
Or
known that's
electric
one of
fields
the
or whatever.
variables associated with weight, phase shift. So I don't know. I mean, you can look it up.
Okay, can you make something change its weight regardless on what it's made of using
Can you make
electromagnetic?
something
Yeah,
stick to the
weight
side of a
isn't a thing of
ball with just
itself.
gravity? Like
Weight
you're
isn't a
asking
thing
or
of
It's not my
itself.
requiring.
claim.
You've
Yeah,
got to
weight's not a
no, but
thing.
you're demonstrating.
Weight's not. All right, fuck it.
My bad, Dicey. You go ahead, man. I actually got to get back to work, though.
Oh,
Shit. Sorry,
you're
Dicey.
attributing a source like an explanation for what gravity is. So and saying you can do things with gravity that haven't been demonstrated. I'm not doing any of that. My only
You're
assumption
assuming
of
mass
gravity is that
attracting
things.
mass. No, you're wanting me to come
I'm
up and
not.
show you how. No, yeah, you basically you invoke that right within my paradigm instead. Well, you need to show me how electricity affects weight, right? And there is evidence of that. There is technology that does that in the form of like being able to make things levitate.
That's not what I
So
asked it for. I said regardless
what?
on what's made of, right? So if
Weight's
you
not a
do
thing of
that,
itself, Bacon. It's not like you can change
hang. Yeah,
weight. It's not a thing. It's a relationship.
the way a kilogram of wood reacts with strong magnetic field is not the same thing as a kilogram of lead, and it's not the same way as a kilogram of iron, and it's not the same thing as a kilogram of water. Like those things interact with the electromagnetic field differently. So if you make the change of one, if you make one of those things change the weight by a certain percentage, by like measuring with a scale, that's not going to be the same difference if you measure something else that has the same mass, so it had the same measurement before, but now it's going to have a different one. So that doesn't work. That's not how weight works.
Weight is correlated with density. That's all it is. And electrical potential and density correlate.
How many gallons of
All
water do you
right.
think is in a rain cloud, Bacon? And how much does water weigh per gallon? So if you're able to get all those thousands of pounds up there in the sky, I mean, it should tell you that the phase of something changes the relationship of how weight reacts to it.
What? Phase of what?
What? You never heard of a fucking rain cloud?
No,
You didn't
I did hear
follow
about a rain
everything
cloud. I'm
I
not
just
sure
said?
what is the phase of a rain cloud. What the hell is that?
You don't know what a phase of matter is, Bacon? You don't realize that matter exists in like four
I
different
realize
types of
matter exists.
phases? You have
Explain me
liquid,
what phase is.
you have
It's not a
solid.
phase.
Stop interrupting. Yeah, you can stop interrupting now. Thank you. So you have liquid, you have solid, you have gas, and you also have a state of plasma. But the
All right.
question I asked you, yeah, please stop interrupting, dude. I know this is difficult.
I just said all right.
All right. So again, the question I asked you was, how do you get gallons upon gallons of water in a rain cloud, not sticking to the globe model, hovering up above
What's one thing he has to
with
do with
all
the
that
other?
weight? The point is, this phase affects weight.
Sure,
Weight's not a
the
thing
state
of
of matter,
itself.
if that's what you mean by phase, because your examples were liquid, gas, plasma, and solid. Then obviously, if certain material is in a solid state and it's in liquid state, they have different densities. Sure, like we all know that. You just switch the word phase, and that caught me off guard because I have never seen anyone referring to the state of matters as phase.
I think he's finding actually a pretty good real world example of how the idea of where like mass attracting mass, like that is the primary cause of your downward vector. There's was it millions of gallons of water up in the sky for some reason. How do you resolve that? I think that clouds personally have an electrical value to them. I can show evidence for that if you really want it, but I mean, I'd
Well,
more
there's
like
literally
to
tons
see
of
how you
air
handle
too.
the idea of that billions of liters of water are up in the sky and they fall down regularly.
Well, there are billions of liters of air as well. Like, why is that an issue?
Because water weighs more than air.
Yeah, when it's liquid.
Yeah, and that's what comes from the sky. If you haven't noticed.
Yeah, that's why it falls. It's called rain.
Yeah, so how does it get up there?
By becoming gas.
What causes its accumulation? It's
What
a
do you mean it's
gas.
accumulation?
Gas is trying to get away from everything else. Now you've got these clouds, they're collecting the water. How's that happening?
Hang on, gas doesn't try to get away from everything else. Gas molecules
Yes, it
collide with each
expands.
other.
It fills. It fills. But that's why they call it
Yeah, there is no
condensation.
gaps of. Yeah, there is no gaps of gas in the atmosphere, so like that's not an issue.
What?
The
I'm talking
pressure
about
is
the
equalized.
accumulation of water in the sky, a cloud, right?
Yeah.
That thing floating
Yeah.
through the sky. Why is
Yeah.
there water inside of that? It's in water. It's water
Because
in the phase
water
of liquid as well,
evaporates,
right?
and when it evaporates, it becomes just as dense as nitrogen. At least nearly as
And then
dense
it
as nitrogen.
accumulates, right?
What do you mean it accumulates?
It concentrates. It's no longer a gas. It starts then forming into liquid droplets in the sky. How is it doing that? How are they coming together?
Well, if the temperature of the water vapor drops, then the molecules of water that are in vapor form can't stay in vapor form, so they start condensing.
And so why
Then
they
become denser.
collect into a cloud then? Why do they
Yeah,
concentrate
that's how
into
clouds
the...
form. When the temperature drops and the water vapor starts condensing, then you start having water droplets. Then you see a cloud. Before the water condenses, there is no cloud. It's just water vapor, which is invisible.
So you don't wonder why the cloud concentrates into one central source at all?
The question
presumably
isn't
all that
making a lot of
water
sense. It's
prior
not.
to
It's
it
not like
becoming
the
a
water
cloud.
came together. Yeah, there is already humidity in the air. For example, water evaporates from rivers and
You're just
the
talking
oceans.
past this point.
Oh, the question doesn't make a lot of sense. It's not like water was
Yeah, it
spread and
does. It
then
makes
it
perfect
decided
sense.
to get together. There
He's talking about
is humidity everywhere in the atmosphere.
he's talking about how a cloud forms, right? And what allows that cloud to formulate.
I already explained that. You have humidity in the air, which is in water vapor, and for the certain amount of water vapor to be in the air, there needs to be a certain temperature. If you drop the temperature, there is less amount of water vapor that you can fit in the same space of air. So if the temperature in the air becomes lower than what's called a dew point, where the water starts condensating, then the water starts condensating.
Well, you're just
That's
talking
how
about the
clouds form.
conditions, the required conditions for a cloud, but you're not talking about the bonding. I think he's looking at
The bonding?
yeah, there's like some sort of an electrostatic bonding between the molecules that allows that cloud to formulate.
Yeah,
Sure.
okay, Bacon, as far as weather phenomenon is concerned, you know that something let's say something pretty crazy. We got hit really hard the other day. I think 50 mils, so 50 milliliters, sorry, dropped in approximately half an hour. Right? 50 milliliters in half an hour. Where's all that frickin' water coming from? It's almost like I don't quite understand it myself, even, but I know that it can't just be like the standard air that I'm breathing in. It must be super saturated in water for some reason, and then at some point it flicks over because it must be always up in the sky, right? Like it's super saturated with water, but you can see through it. You can't see the water, presumably transparent. And then at some point it flips over and it starts condensating, becoming clouds, concentrating, and then precipitating. Now, in your, what you've just gone and explained is say you take a cubic meter of air, right? And you try to tell me how much water you can fit into that air. I doubt if you can really, it's a very large amount of water apparently that you can fit into these clouds somehow.
It depends on the air
all of a
temperature.
sudden coming from the sky.
Yeah, that depends on the temperature of the air. The hotter the air, the more water vapor you can have in it.
The more water vapor you can have in the hot air, but the hot air expands as well. So all of a sudden,
there's a calculation. There's a calculation that when I finally looked it up, like broke my brain a little bit. When you look at like say you're at sea level, it's 20 degrees C and 100% humidity. Like how much mass of water is in a cubic meter of air? And it's 17.5 grams of equivalent liquid water in just 1 cubic meter. And granted, that's 100%.
And how much mass and how much mass dry air have in that same volume?
I don't know. I'd have to look up the mass of the air. I'm just talking about the physical amount of water that is in 1 cubic meter of air.
But I'm asking that because I think we kind of how do I call it? Underestimate? No. What's the word? Yeah, I'm going to use that word because I don't know the right one. Yeah, we kind of underestimate how much mass air has, right?
Yeah.
We kind of assume it isn't there because we don't feel it, but like it makes a huge pressure. Like
Okay.
1 atmosphere is a huge pressure. So like there's a lot more mass in a liter of volume of air than it feels like.
It's 1.29 kilograms for a cubic meter of air at 0% humidity at sea level at 20 C.
How much?
1.29 kilograms.
Right. And how much water that has? You said?
17 grams and some change.
And so now that sounds like a lot less, right?
Yeah.
What sounds like a lot less?
17.25 grams of water in a cubic meter of air at 20 degrees Celsius at 100% humidity. And at under the same conditions, at 0% humidity, it's 1.29 kilograms of air in 1 cubic meter at those same atmospheric conditions. Sea level, 20 degrees Celsius.
And by the way, for that air, for that dry air to absorb the how many grams you said of water?
17.25.
Right. So to get those 17.25 grams of water, it's gonna lose more than that of pure air, because 100% humidity air has less mass than 0% humidity air.
Yeah,
so
water is less dense than air.
Water vapor is, yeah.
Yeah, water vapor.
Anyway, so yeah, I mean, interesting questions with the clouds, but there's no mystery of how clouds would work under the fact that they have weight.
Well, that was my only point, was that you got that much weight defying gravity, right? All due to phase shift.
You got 1
I failed to explain how that's defying gravity.
For the U.S. folks, that's 1.25 tablespoons of water in a cubic meter of air at 20 degrees Celsius at 100% humidity. That's enough water to see in a cup, like a shot glass of water, effectively.
And there's like almost 20 kilograms of air there?
1.25.
Oh,
1.29 kilograms.
Okay. No, okay, almost 1.3 kilograms. All right.
I mean,
Yeah,
clouds.
Those are all very good questions about. Sorry to cut you off. Let me
go ahead.
just say this. Yeah, those are very good questions about how clouds work and how humidity work and how clouds form and all that. Those aren't refutations of gravity. Those are just good questions about how clouds form.
I mean, clouds are liquid water, and they are falling.
Check out that cloud that I just posted, dude.
Gravity.
Yeah, I see it.
So where's that cloud coming from exactly?
Oh, it's formed.
I don't know. I don't know how it formed.
It forms
At
in
some
midair. It
point,
doesn't come from somewhere.
yeah, the water
So
vapor
there's all this
eventually
water.
condenses into liquid water.
So you got
Exactly.
what is it? 17.25, I believe it was, milligrams. What was it? Milligrams? I think actually milliliters, milligrams are the same. In cubic square meter, I think it was, of air.
Yeah, that's at 20 Celsius.
Okay. At 20 degrees Celsius. So what happens then? Is that like, so let's just take this cubic meter of air, right? Now what's happening? It's heating up and presumably floating up into the atmosphere.
Yeah,
Well,
that's what
the
less
water
dense
is
air
turning
does.
in. Yeah, the water vapor is turning into a. I mean, the water's turning into a vapor, into a gas, which is less dense than the atmosphere, which is primarily right. It's nitrogen, and so it will rise up, and then when it cools sufficiently, it condenses back into a liquid, and when it's a liquid, it becomes a visible cloud. And you can watch on a
Okay, then
summer day. You can literally watch clouds come out of nowhere as